Hello, hi, namaskar everyone. Just give me a quick update. Am I clearly visible and audible? So we are welcoming you all in this session where we are going to cover the entire chapter determinants in this one single video. Yes, you heard me right. We'll be covering this entire chapter determinants for your JEE preparation in this one single marathon session. Now, most of you must be wondering, sir, can it be covered? Of course, it cannot be. But can we cover it in terms of backlog? Can we see it as a quick revision? Can we cover it at least in terms of theory? Yes, we can. Sir, will be developing that level, same level, which can be attained with the regular batch with this one marathon session? No. To attain that level, to get that level, you should always get more practice. So of course, with a simple marathon, you can get theory, you can understand the concepts, you can learn the formulae, you can get definitely all the insights. But of course, you cannot always get the depth. I'll try to bring you the whole width of this entire chapter determinant, but to gain the depth, to understand it to its core level, you got to practice as many questions as you can. So thank you so much for such a great response, whoever is doing it. Thank you so much for that. So thank you so much for this clarity. Great, great, great. We'll do that as well. Don't worry about that with me. With this, shall we get started with this discussion? Now, if I'll begin with my discussion, first of all, I'd like to tell you what all we'll be covering here in terms of talking about determinants. Of course, I'll tell you how do you expand a determinant, the different methods, the different techniques, which you might have probably learned in 11th standard as well. And there, I'll be telling you a short technique as well, through which you can definitely and very quickly expand a determinant. Thank you so much for such a great response. Thank you so much for showering your love. Great, great, great. With that, I'll of course talk about minors and cofactors. This is very widely used in matrices, but determinant and matrices are interrelated chapters. So there we'll be studying and talking about them as well. The third thing, yes, a lot of students constantly keep on asking, sir, we have understood this, that this is an operation which we do, but what is the application of it? Why are we learning this? So all the major applications of determinants from the perspective of coordinate geometry also will be exploring here, the major ones. Then of course, we'll talk about properties of determinants. There I'll be telling you the different observations which you can make on a determinant so that you can learn or expand it more quickly. So through different properties, you can know its value in a more quicker manner. That also will be understanding. Along with this, yes, Kramer as a mathematician suggested you that how can you solve system of linear equations. So let's say there are two equations in two variables, there are three linear equations in three variables, and so on. And if you want to do it with the help of determinants, you can use Kramer's rule that also we'll discuss. And this part here is very highly loved by JEE, because JEE uses or asks questions on that Kramer's rule and its applications, of course. Then, of course, we'll talk about homogeneous system of equations on which majority of your questions are asked by JEE Main. So this is that particular chunk from where JEE loves asking questions. Now, the other part here is, yes, three things with which we'll be culminating this session is differentiation, integration, and summation of determinant. Can you believe that? So differentiation, integration, and summation can also be done on determinants. So shall we get started with our discussion? First of all, without even explaining what is a determinant, I want you all to understand the sign scheme which will be following in a determinant. Sir, why? First of all, when we talk about determinant, we take the determinant of a matrix. Sir, what does it mean? It means, let's say there is a matrix. There is a matrix. Let's say there is a matrix. Sir, what is a matrix? Matrix is a tabular arrangement of data. It's merely an arrangement. So for example, here I am creating a 2 by 3 matrix. So 2 by 3 matrix would mean there are 2 rows and 3 columns. So there will be technically 6 elements here. So 6 elements like 2 rows and 3 columns, A, B, C, D, E, F. This here is a matrix. I hope very simple observation here. But if I take a square matrix, sir, what do you mean by a square matrix? Square matrix here means that if you are taking a matrix whose number of rows and number of columns are same. If you happen to see a matrix whose number of rows and columns are same, then we call it to be a square matrix. So whenever a matrix is defined in such a manner that its rows and columns are same, then we say its determinant can be found. Sir, what is determinant? What do you mean by finding the determinant of a square matrix? How do we find it? Why do we find it? Have patience. I'll be answering all your questions one after another. But right now, you have to have patience. Can we continue with that? So first of all I'm trying to tell you is a matrix of third order, which means 3 by 3, means it has 3 rows and 3 columns. For example, 3, 2, -1, 0, 5, 7, and you have 2, 1, 3. So that's a matrix of order 3, which means 3 rows, 3 columns. Similarly, I can have a matrix of order 2 as well, which is, let's say here 2 means 2 rows, 2 columns. It can have elements like 1, 2, 3, and 0, let's say something like that. There can be a square matrix of order 1 as well. Let's say 1 order means what? 1 row, 1 column. So it will have only one element. Let's say it is 5. So these are the matrices, square matrices of order 1, 2, 3 respectively. Everybody got that? Now, if somebody is asking you to find the determinant of these matrices, why? Because you can take the determinant of only square matrices. Do you remember that? So here, if I ask you to find the determinant of matrix C, so determinant is denoted by this 2 lines, including that matrix. So determinant of C, I hope you are not confusing it with the determinant with modulus. It is not modulus. This sign here represents the determinant. So you are taking the determinant of a matrix C. Thank you so much, Deeps. With that, if you are taking the determinant of a 1 by 1 matrix, so there you are simply taking the determinant of 5. Now, please don't confuse this with mod. This here does not mean modulus of 5. This is determinant of 5. And always remember, determinant of a 1 by 1 matrix is always that value. So here it is 1 by 1 matrix, which has 5 as an element in it. So its determinant will be 5 only. Sir, what are you trying to say here? Let's say had it been -5. The matrix C is -5. It is a 1 by 1 matrix, order 1, 1 row, 1 column. So it's, let's say one element is -5. So its determinant will also be -5. Please don't say it is mod of -5, then it is 5. I did not say so. I've already told you clearly that here it is determinant. It is not modulus. This sign here represents determinant of a matrix. It is not modulus. Did you all get that? In that case, sir, how do we find the determinant of a 2 by 2 matrix? Let's talk about that as well. Don't worry about that. If now I wish to find out the determinant of a 2 by 2 matrix, that process is also absolutely simple. Let's say I'm willing to find the determinant of matrix B. So to have that, what I'll do is determinant of 1, 2, 3, 0. Now determinant for a 2 by 2 matrix can also be found with a very simple operation. What you simply do is that you multiply this 1 with this 0. So 1 into 0 you do. Then you subtract this 3 into 2. Then you subtract this 3 into 2. So 1 into 0 is 0. 3 into 2 is 6. So -6 here. -6 here is the value of determinant of B. Are you first of all observing and noticing the basic difference between a matrix and a determinant? I'm simply trying to tell you a simple fact that if it is a matrix, it is an arrangement of a data, just like an Excel sheet. In an Excel sheet, you have rows and columns. So what does that entire sheet mean to you? It's simply an arrangement of the data. So that sheet does not have a value. I hope you're getting it. That sheet, whole as a sheet, is simply a sheet. So matrix B is simply a matrix B, which contains elements here. So this matrix B does not have a value here. It is an arrangement. So 2 by 2 means 2 rows and 2 columns. But when you talk about determinant of a square matrix, then it is a value. So if you are taking the determinant of this matrix, it will be this here, this. Anish, I'm telling you, it is not mod. It is not mod. It is determinant. Don't confuse determinants with mod. Modulus is a different operation. Determinant is a different operation. Anish, for your kind information, look at the channel. It is PW JEE English. So we are supposed to communicate in pure English. Sincerest apologies for disappointing you. Now, with this, if I now talk about finding the determinant of matrix A, can we find the determinant of matrix A? Sir, this is a 3 by 3 matrix. So for a 3 by 3 matrix, is there a mechanism? Is there a modus operandi we follow? Yes, we do that. So to understand that, I will now introduce the sign scheme. I will now introduce the sign scheme. This sign scheme technically is having its own convention, its own derivation, its own proof there. What is that proof? Actually, to find the determinant of a matrix, you deal with cofactors. Sir, what are cofactors now? That entire discussion of minor and cofactors will help you in understanding how do we find the value of a determinant. But right now, I'm simply telling you that forget this 2 by 2, forget this 4 by 4, which is absolutely not in your syllabus. But if you're talking about a 3 by 3 matrix, Anish, focus on this statement now. Let's say you're given a 3 by 3 matrix and you're supposed to find out its determinant. So first of all, we'll follow a sign scheme. Sir, what is the meaning of this sign scheme? How do we find this? How is it created? That all I'll explain later in the upcoming slides of this video. Don't worry about that. But right now, just accept what I'm saying. The part I'm saying or mentioning here is simple, that with a 3 by 3 determinant, the sign scheme which we follow is plus, minus, plus, minus, plus, minus, plus, minus, plus. So luckily or coincidentally, with the 3 by 3 matrix, the sign scheme which you follow is plus minus plus, plus minus plus, alternatively minus plus minus, plus minus plus. Sir, what are you trying to say here? We are absolutely clueless. I get this. Now, I am trying to tell you a simple fact here is that let's say I am willing to find out the determinant of this matrix A. How will I do that? So to have that, you have the liberty to expand this determinant. Let's say this was matrix A, but I want the determinant of this matrix. So the determinant of this matrix means what? Determinant of A. That means this. Now the beauty here is that if you want to find out the value of this determinant, you can expand it along with any row or any column. You can expand it along with any row or any column. Which means, let's say I have chosen first column. So I am expanding it along with column 1. Now, when you have decided to expand it along with column 1, what you do here is you write the elements of column 1, which are of course 3, 0 and 2. So I'll write this 3, I'll write this 0 and I'll write this 2. Everybody got this conclusion, or shall I repeat that part? Then, sir, what do we do? In that case, what you do clearly here is you look at this 3, you remove the row which contains this 3, you remove the column which contains this 3, and then you multiply these elements in this manner, the way you were taking the determinant of a 2 by 2 matrix. Do you remember that? I repeat, what you do is you remove this row and this column. So ultimately you are left with these 4 elements, and then you know how to take the determinant of a 2 by 2 matrix. Do you remember that, everybody? So that's exactly what I'll do here. So for this 3, I'm left with these 4 elements, which when I multiply 5 into 3 I'll do, then 1 into 7 I'll do, but with 1 into 7, I hope you remember, I'll put a negative sign. So 5 into 3 I'll do first, and then 1 into 7 I'll do second, but I'll put a negative sign. Everybody understood that, all the participants? Now, once you have done this, once you have performed this operation, second thing, I am expanding it along with column 1. So in column 1, there was this element 0. So I'll remove the row in column which contains 0, which means I'll be left with 2, minus 1, 1 and 3. Yes or no? If I remove this row in this column, I'll be left with these 4 elements, and on these 4 elements again, I'll be performing the same operation. Again, which means I hope you are noticing this 2 into this 3, that is 6, minus this 1 into minus 1, which is, I think, minus 1. I hope no confusion so far. Now the third element, which is 2. Again, look at the same operation which I'm going to do here. Remove this row and this column. So if you're removing this row and this column, which contains 2, I am again left with 4 elements. And if I take the determinant of these 4 elements, it can be taken in this manner. Great, Deeps. That's brilliant. You are responding and you're coming up with the answer so quickly. With that, what I'll be doing here is 2 into 7 I'll do first. So this will be 2 into 7. And then minus 5 into minus 1 I'll do. So this will be 5 into minus 1. Now you're supposed to follow a certain sign scheme. What is that sign scheme? Sign scheme meant here for the column 1, the sign scheme was plus, minus, plus. The sign scheme was plus, minus, plus. So here I'll put a plus sign. I don't have to put it. Then minus and then plus. Are you understanding the meaning of the sign scheme we are supposed to follow? Sir, how are we going to learn that sign scheme? Is it not very difficult? I understand this. I'll explain you and I'll give you a logical explanation that how do you develop that sign scheme and how do you learn it and memorize it with the help of the concept of cofactors. But right now, if I simply tell you, if you have found the value of this determinant, what would that be? I hope you're understanding it. This is 3 into 5 into 3, 15. This is 7. 15 minus 7, that is clearly 8. Yes or no? Then this is 0 into anything, that remains 0, so it doesn't matter. Minus 0 plus 0, you don't have to write it. Then what you have next is, I hope you're paying attention to this, 2 into 7, that is 14, 5 and 1, that is plus 5, 14 plus 5 is 19, 19 into 2 is 38, 19 into 2 is 38, yes or no? So this I think is 24. So your final value will be 24. Your final value here, can I write it directly here? This is your 24. So your final answer will be 24 plus 38. Everybody got this? Everybody? So 38 plus 4 is 42. 42 plus 20 is clearly 62. That will be your final answer. So Deeps, I think 72, it's incorrect. 62 will be the correct answer. Now, when I started expanding it, I told you in the very beginning of that discussion that you can expand this matrix A, which is a 3 by 3 matrix, along with any row or any column. What did I mean by that? I simply meant a simple fact here that if you are expanding it, let's say with respect to second column or third column or third row, you will always get the same value. Trust me. Trust me. Whichever row or whichever column you choose for its expansion, if you are simply following the right expansion method, if you are simply following the right sign scheme, you will always get the correct value of the determinant and luckily the same value of the determinant. Have you all digested that statement? Did you all understand that statement? So first of all, when I talked about expanding the determinant with the help of a simple rule, did you all get that? Did you all understand that? But there comes a more interesting rule which I wanted to discuss as a short trick or a short technique which was developed by Sarrus as a mathematician. So what did he say? He suggested that let's say you are given a matrix. You are given a matrix A1, A2, A3, B1, B2, B3 and C1, C2, C3. That's your matrix. And you're supposed to find out its determinant. So how do we find the determinant of a 3 by 3 matrix? So what Sarrus suggested was, first step, repeat first two rows. Repeat the first two rows. So if you repeat the first two rows, what would it mean? A1, B1, C1, I'll write again below the third row, that is A1, B1, C1. Then second row, A2, B2, C2, I'll write that again below the first row which I have repeated here, that is A2, B2, C2. Everybody with me so far? Have you all understood this operation which I have just performed? So there was this determinant A1, A2, A3, B1, B2, B3, C1, C2, C3, which I was trying to figure out. But instead of using that standard method of expansion of determinants, if I use a short technique here, which initially may look a little difficult to you because it is, of course, initially it looks difficult, but gradually later on, you will see that it is even better than that standard expansion of a determinant. But this Sarrus rule right now is applicable for a 3 by 3 because mostly in your syllabus, you deal with a 3 by 3. Now, once you have repeated the first two rows, what you do next is you take the product along the principal diagonal elements. So I'll multiply A1, B2, C3. Then I'll multiply A2, B3, C1. And then I'll multiply A3, B1, C2. Yes or no? So this product A1, B2, C3, A1, B2, C3, I'll write here. Then this product A2, B3, C1, I'll write here. And the third product, A3, B1, C2, I'll write here. Everybody got that? Everybody with me so far? Are you able to digest and understand all what is being said? And then you add these three values. And then what you do is you add these three values. So you got a summation, and that summation, let's say we are calling or treating as P. So this summation I have gotten, I am treating that summation as P. Similarly, I will find the product along the non-principal diagonal elements. So there I'll get A3, B2, C1. So A3, B2, C1, this is the product I have gotten. Next product will be A1, B3, C2. Next product will be A1, B3, C2. The third product will be A2, B1, C3. A2, B1, C3. And again, what I'll do is I will add these three products which I've gotten, and that sum of these products I'll call as N. Now the beauty of this method here is very simple, that you simply subtract this N from P, and that will give you the value of the determinant. Yes. If you don't believe me, I'll prove it with this example which we have just discussed. This was your matrix whose determinant we were trying to find out. So let us discuss its determinant with the help of Sarrus rule for a while. I hope we can do so. So let me write it one more time so that we do it more correctly. This is 302,251 minus 173. Yes or no? This is the matrix 302, right? So this is 302. Yes or no? This is your matrix A. This is your matrix A. And its determinant we are trying to find out. Now let me apply the Sarrus rule here. Let me apply the short technique here. So what does that short technique say here? That short technique says a very simple operation you are supposed to apply. First of all, what was the step 1? Repeat the first two rows. So first two rows are your 3, 2, minus 1 and 0, 5 and 7. Then what do we do, sir? After that, I will take the product along the principal diagonal elements, which means 5 into 3, 15, 15 into 3, that's 45. So I'll write this product here. Getting it, everyone? The next will be 0 into 1 into minus 1. So 0 into anything is 0. So I don't have to write it. But for the sake of simplicity, I'll write it here. The next product will be 2 into 2 into 7. So I hope you're getting it. 2 into 2, that's 4. 4 into 7 is 28. So this gives you a 28 here. This summation I've got it. That's your P. Do you remember that? From this P, I'll be subtracting the other three sums, which are going to be minus 1, 2 and 5. That I think is minus 10. Yes or no, everyone? This is going to be 7, 1, 3, which is of course going to be plus 21. And then it is going to be 3, 2, 0, which of course is going to be 0. Everybody understanding this method? Everyone is able to digest this method, this short technique, which was given by Sarrus, the mathematician. So here, if I simply do this, what am I getting here is 21 minus 10, that is 11. And if I subtract 11 from here, 28 minus 11 is I think 17. So 45 plus 17, that is going to be of course your 52, 62. So your answer will be 62. And that's exactly we have gotten with that standard expansion of determinants. There I'm simply telling you one simple fact which you should remember with yourself is this, that if you are asked to find out the expansion of a determinant, instead of using that standard method, please use this. This Sarrus rule is even more interesting, and this is more beautiful, and this is more easy, and this is more efficient. Will you all remember that, everybody? Any confusions, doubts or queries or concerns so far? If you have any, please ask in the comments. I'll definitely revert. If there is any genuine query or concern. With that, I hope no confusion on Sarrus rule. So this is a question, this is an example, this is a homework question I'm giving to you. Sir, how are we going to attempt it as a homework question? You can by simply following our WhatsApp channel. On our WhatsApp channel, you will be getting this entire PDF uploaded as session notes after the session, of course. Sir, how do we get to your WhatsApp channel? To have that, there is a link given in the description through which you can follow our WhatsApp channel. Great, 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 brilliant. With this, I hope you know how to do it. All you'll simply do is 3 to 5, 9 minus 1, 4 you will do here. So 3 to 5 you'll repeat here. 9 minus 1, 4 you'll repeat here. Then what you'll do is you will find the product, this, and this. You will add those values. You will find this product, this product, this product. You will add those values. And from this value, you will subtract this value. And that will be the determinant. Is it not absolutely easy, simple, and interesting? And trust me, the chances of you committing the error is really less, is absolutely less. Trust me. With this, if I move ahead, now, if I give you a question asked by JEE Mains in 2025 based on simple question or simple expansion of determinants, can you solve that? Now, if you want to participate in polls, you all can. I have started a poll. Now, when I start a poll, what is the meaning of it? Finding difficulty in using property of dependent, what to do? Rajesh, I'm going to discuss all of that. Don't worry about that. Here, if I am asking you to use PyLens app to participate in polls, it is one of those amazing apps through which you can not only participate in the polls of PW Lives, but if any random video you are watching on YouTube, you can generate short notes, quizzes, mind maps, previous year's questions, and a lot more, that too at absolutely free of cost. So that is the advantage of this application PyLens. Sir, how do we download this application PyLens? To download this application PyLens, you can download it from either Google Play Store, or if you're watching it on the browser, on the desktop or laptop, you can download it from Chrome Play Store or Chrome Store, whatever you want to call it. Now, if I ask you how to solve this question, I have already started a poll. So this poll must be visible to you if you have that PyLens application installed in your phone, of course, not in you. So how do we solve this question? Let's quickly start discussing this. I hope everybody is noticing what all we are given here. So it says sum A and B. You are defined this is as a function f of x. So this is a function which is a 3 by 3 matrix determinant technically. X is not 0, and when x approaches 0, fx is given by lambda plus mu a plus nu v. Okay, great, brilliant. Now, they are asking you the value here. First of all, please remember, whenever limit is applied on f of x, the beauty of limit is that limit can be applied on all the elements. Limit can be applied on all the elements. So if I am treating it as a matrix fx, where I'm applying a limit on this matrix f of x, then always remember here, limit when you apply, then it can be applied on all the elements. So there, if I'm willing to apply limit here, which means limit x approaches 0 on f of x. So shall I tell you this basic fundamental property which you must have studied, possibly in 11th standard, that when sin x upon x you do, when x approaches 0, it is always 1. Do you all remember that, all the participants? Sin x upon x become almost equal, very closely equal, that when x approaches 0, that means their ratio will be 1. Which means what? Which means sin x upon x, can I not treat it as A? This is 1, this is B. Yes or no? This here is your A. This is sin x upon x, which is 1. So 1 plus 1 is 2. And that's again your B. Give me a quick update on that. In the next conclusion, this here is your A. This here is 1, and this is B plus 1, because sin x upon x is 1 when x approaches 0. Give me a quick update on this. Have you all gotten this result? Did you all get this result? Now, if you all have gotten this result, sir, I think the last step which you are supposed to perform is expand this. Now, there are two methods. You use the general standard result of expanding a determinant, or you use the Sarrus rule. Whatever suits you, whichever method suits you, you can use that. I'm really sorry, there is a simple correction. It should have been A plus 1. A plus 1, 1B, A, 2B, A, 1B plus 1. Yes. So whatever suits you, whatever method you want to use. Now, sir, if you wish to expand it here, I will say general result, I'll use it here. So let's say I am expanding it along with row 1. Although you can use properties of determinants, but in this one shot marathon, since right now we haven't studied those properties. So right now I'll simply ask you to expand it with the general expansion result which we know so far. Kavyan, you should attend the chemistry class right now. Why would you watch this class right now? Then come back and watch the recorded lecture. I think that will be better. So if I'm expanding it with respect to row 1, I hope you know how to do that. First element, that is a plus 1. Then your second element, which is 1. And then your third element, which is b. And with respect to row 1, the sign scheme which we follow is plus, minus, plus. Do you remember that? For a 3 by 3, plus, minus, plus, minus, plus, minus, plus, minus, plus. So sign scheme will be plus, minus, plus. Yes or no? So I have applied the sign scheme. Now I need to find the other parts which are technically nothing but the minors here. So let me quickly start finding them. So I hope you remember that general expansion result for a 3 by 3 determinant. What was that? For a plus 1, it will be this minus this. Yes or no? So it is 2b plus 2. It is 2b plus 2 minus b. Give me a quick update on this. Everybody got this result? Then for this minus 1, it will be this minus this. Yes or no? So this will be ab plus a. This will be ab plus a, and this will be minus ab. I hope you are getting it comfortably, all the participants. Yes, good evening everyone. With this, with respect to this b, which is your this element here, this will be this minus this, which is a minus 2a. Yes or no? So it will be a minus 2a. I'm writing it in a more detailed descriptive manner so that when you revise, okay, great. When you revise these notes, you can understand things more clearly. Now, what do we do, sir, here? I think you have gotten the answer because you just need to simplify this. You just need to simplify this. So when I start simplifying it, 2b minus b, that's b, so it is b plus 2. It is a plus 1, b plus 2. So it is a plus 1 times clearly b plus 2. Everyone getting this? Then minus 1. Minus 1 times ab minus ab are cancelled, so this is a. So this is clearly minus a. Then here, if I pay attention, it is ab minus 2ab. I hope you're getting it. Or rather, I'll say this is minus a, so b, it is clearly minus ab. Yes or no, everyone? I think I'll simplify it further. So when I simplify it further, what I clearly get is this is your AB, this here is your B plus 2A plus 2 minus A minus AB. I repeat, this is AB plus 2 plus 2A plus B. Getting it or not? And with that, AB and AB are clearly cancelled. So that gets cancelled. What else am I getting it cancelled here? 2a minus a is a, so this is a plus b plus 2, but this value we are given as lambda plus mu a plus mu v, right? So with that, I think lambda is your constant term. Lambda is your constant term. That gives you lambda as 2. So lambda we crack as 2. Then mu, if I want to crack coefficient of a, which is 1. And nu, if I want to crack, which is the coefficient of v, which is also 1. So there I get lambda plus mu plus v as 2 plus 1 plus 1 whole square is what I'm supposed to figure out. So 2 plus 1 plus 1 is 4. 4 square is 16. And I think it is given in option A. And I'm sure some of you must have downloaded Pylons by now. And some of you must have participated in it. So let's see how many of you have gotten the correct answers. Nobody participated? Quite disappointing. I hope you are taking these sessions sincerely and you are utilizing this opportunity where we can avail this marathon, one single marathon, to revise entire chapter determinants in one shot, in one go. Shall I move ahead from here? That's good, Vinayak. That's brilliant, students. Good to have you all. Which chapters must to cover in class 11 for JEE? All chapters. Now, there is a very interesting, a very beautiful property, a very insightful property. If you remember, trust me, you'll not be solving only JEE Mains questions very quickly, but also JEE Advanced questions too. Sir, what does it mean? Let's say in a question, you see or you're asked to find out the determinant here. And this is the determinant in which, sir, once more repeat the last step. I will say here, I got my answer as a plus b plus 2. They give you the answer as lambda plus mu a plus mu v. So if I compare the terms, lambda will be your constant, which is 2. Coefficient of A will be mu, which is 1. Coefficient of B will be nu, which is 1. So I think I have 2, 1, 1, which were supposed to be added and squared. And I think I got my answer with that. Yes or no? Now, the second thing which I'll do here is, if there are certain terms which are in AP, if there are certain terms which are in AP, first of all, forget this whole concept. Can you help me with a better result here? Let's say there are certain terms which are in GP. Let's say A, AR square, and so on. These are the terms of a GP. Do you remember that? Now, if I take log of all of these terms, which means log of A, log of AR, log of AR square, and so on. So I have taken logarithm of all these terms. So do you remember this result which you must have studied in 11th standard, that if certain terms are given in AP, and if you are taking logarithm of all of those terms, it will be, sorry, I'm really sorry. If there are certain terms given in GP, and if you are taking logarithm of all of terms given in that GP, it will be forming an AP in that case. Do you remember that result which you must have studied in 11th standard while studying the chapter sequence and series? That logic I am trying to give you here, that right now I'm not giving you the logic here. Why is it happening? But right now I'm just giving you the result here, that let's say there are certain terms in AP. There are certain terms in AP. Let's say x1, x2, x3, x4, x5, and xn, they all are in AP. So if I take those terms which are in AP, and I ensure that they remain equidistant, the difference between those terms is equidistant, which means, let's say, for first row I have chosen x1, x2, x3. Then I move n terms ahead, and then I choose xn plus 1th term, xn plus 2th term, and xn plus 3rd term. For example, the first 3 terms I have chosen x1, x2, x3 of an AP for the first row. Second row is x11, x12, and x13. So 11th term, 12th term, and 13th term. Then again I take a jump of 10 more terms, and I choose 21st term, 22nd term, and 23rd term, let's say, to make you understand this. Or in a better language, it can be x2n plus 1, x2n plus 2, or x2n plus 3. If you have terms in AP, of course, these 9 terms will also be forming those 3 terms pairwise in AP or triplet wise in AP. And row wise, they are equidistant. With that, remember this as a fact, that even without calculating it, you can say that its determinant will be 0, which is the broader version of this property. I'll give you a simpler version as well. Remember it as a fact. Let's say in a determinant, I am given certain values. Let's say A1, A2, A3, A4, A5, A6, A7, A8, and A9. This determinant's value I'm supposed to figure out. Without any hesitation, you can say that its value will be 0 if A1, A2, A3 until A9, they all are in an AP. If they all are forming an arithmetic progression, its determinant will be 0. You should definitely, Bhanu, if you believe that you can get better, you can score better, you should think of doing it. It is absolutely a good idea to do so. So I think you have gotten a decent clarity about this property, that if terms are in AP and if you take its determinant, it will be 0. Second conclusion. I am deriving the second conclusion from here. Please pay attention to this part. If there are terms in GP, so A1, A2, A3, they all are in GP. So what we have just discussed, sir, if you take log of them, which means log A1, log A2, log A3, log A4, log A5, log A6, they'll be in AP. Getting it or not? So if I write log A1, log A2, log A3, log A4, log A5, log A6, and so on, it will be an AP. So in a determinant, if you put elements of an AP, I need not tell you, its value will be 0. Stay tuned with our channel. I'll be discussing a lot of strategies related to your concerns. Don't worry about that, Bhanu. I'll be doing a lot of activities. We'll be doing a lot of activities for you. Don't worry about that. Now, one thing we have just learned so far is simple fact, expansion of a determinant. If you have learned that, I am willing to take it further with two more concepts, minor and cofactor, which is actually or internally used in the expansion of determinants only. I am starting 11th June 2026. By when should I complete 11th syllabus? Why specifically 11th June, Sudarshan? I didn't get that. But anyways, you should complete your 11th syllabus by possibly January and February, right? Now, I'll come back to the discussion here. I'll talk about minors and cofactors. Please pay attention to this part. This is very interesting. I'll begin this discussion with the 2 by 2 matrix. Let's say this is a matrix A, which has entries 2, 3, 4, and let's say -1. And I am writing the minor of A. So I'm denoting it by MA. So how do you write minor of A? Let's say I want to write minor of A, which means I want to write the minors of these elements. So for 2, please remember, the minor will be remove this row, remove this column. What are you left with? -1. So -1 here will be minor of 2. So I hope you develop the logic. Sir, for 3, the minor will be 4. I hope you got this. Sir, for 4, the minor will be 3. Did you get this? Or shall I repeat this? For 4, the minor will be 3. For -1, the minor will be 2. Yes or no? For -1, I hope you're getting it, the minor will be 2. So this is you find the minor. Was it not absolutely easy, simple and doable? Did you all get that? The concept of minor. This is how you're finding the minor of A. Now, sir, if we have found the minor of A, how do we find the cofactor of A? So let's say for a while, I'm denoting cofactor of A by CA. So first of all, cofactor of A will be an extension of minor of A. Possibly not, but yes, up to a great extent, we'll be doing almost everything. Almost everything. So here, when you talk about cofactor of A, I figured out the minor of A. Let me write that first. So it was -1, it was 4, it was 3 here, and it was 2 here. This was minor here. Now, if I introduce one simple thing here, let me define the positions here. This element is first row, first column. This element is first row, second column. This element is second row, first column. This element is positioned at second row, second column. Sir, what does it mean? It means, what is 1 plus 1? Sir, 1 plus 1 is 2. Tell me 2 is even or odd. Sir, 2 is even. So if 2 is even, add a plus sign over here. Everybody got my statement? Now, look at this 1, 2. 1 plus 2, that is 3. 3 is odd. So if it is odd, put a minus sign over here. Are you digesting what all I'm saying here? Then, this is 2, 1. 2, 1 means 2 plus 1, that is 3. 3 is odd. So if it is odd, put a negative sign here. Then look at this 2, 2. 2 plus 2 is 4. 4 is even. It is even means put a plus sign here. Which means here, if I'm finding its cofactor, it will be -1, -4, -3 and 2. -3 and 2. Did you all get this? Did you all understand this? Yes, it is the one single marathon session of determinants in which we'll be covering the entire chapter determinants. As we have already started our Lakshya batch in English, where we are covering the chapter matrices as of now, and we have already covered the chapter determinants. So a lot of students have joined us and they have this chapter as their backlog chapter, which they haven't studied so far. So with this one session, we are trying to help all the students who may have missed or skipped the chapter determinants. Are we clear with the intent? Sir, I'm in the 11th standard student. School starts. So by which month should I complete 11 JEE syllabus? I told you already, by January or February. Did you get my point, Sudarshan? Have you all understood the concept of cofactors here? Everyone, give me a quick update. Now, If you have understood how to find the cofactor of a 2 by 2, let me give an example how to find the cofactor of a 3 by 3. But I'll not give you the whole picture here. I'll give you few elements only. Let's say this is a 3 by 3 matrix which is denoted by B, which has elements, let's say 2, minus 1, 0, 7, 5, 3, and then you have 4, 1, and let's say 3. Got this, everyone? Now you can write the minor and cofactor of this entire matrix, but let's say I'm interested in finding the minor of 5. So if I'm finding the minor of this 5, so how do I find it? Minor of 5 is absolutely simple. Just remove the row and column which is containing this 5, which means I'll be left with these 4 elements, Then I hope you know what to do. 2 into 3 minus 4 into 0. Do you remember that? So I hope you remember that. This will be 2 into 3 minus 4 into 0. That will here be the minor of your 5. Which means if I am willing to figure it out, it will be 2 into 3, 6 minus 0. So your minor will be 6. Everybody got this? So minor of 5 here is 6. Everybody got this? Then, sir, we are interested in finding the cofactor as well. So let us now find cofactor of this 5. So tell me the position of this 5. Sir, 1, 1, 1, 2, 1, 3. First row, first element, first row, second element, first row, third element. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. So this element has the position 2, 2. Second row, second column. So you write the minor of 5, which is 6, but this 6 you multiply by minus I to the power I plus j. Sir, what is I plus j? I means the row and j means the column, which means here the row and column of this 5, is 2. So this will be 2 plus 2 here, as I have already told you. 2 plus 2, 4, even, put a plus sign. Had this summation been odd, I'll put a negative sign. Are you understanding why? Are you understanding this formula now? So there, the cofactor will be plus 6. So luckily, minor and cofactor both are same. Tell me honestly, have you all understood the concept of minor and cofactor with utmost clarity? Or shall I re-explain that? Two things I want to discuss here. Remember this. Minor you have already understood. How do we find it? For minor, we simply do this thing that let's say I'm finding the minor of 7. There, I'll remove the row and the column which is containing this 7, and that's how I'll be left with 4 elements. So I'll take it as a 2 by 2 matrix. I find its determinant. It will be the minor of 7. So minus 1 into 3 minus 3. 1 into 0 is 0. So minor of 7 will be minus 3. Yes or no? So minor of 7 here will be what? Minus 3, right? Now, what will be cofactor of 7? Sir, cofactor of 7 will be minor of 7 only with a sign. What is the sign? For this 7, it is positioned at second row, first column. So it will be 2 plus 1. So 2 plus 1 here in our case is odd. So just put a negative sign. So your value of negative 3, which is 3. So cofactor of 7 will be plus 3. Everybody understood that? Can I move ahead from here? Now, if we have discussed minors and cofactors, shall I not tell you? Let's say there is a matrix A whose elements are A11, A12. Let me take a 3 by 3. Let's say its elements are A11, A12, A13. Then A21, A22, A23. Then A31, A32 and A33. Yes or no? And then I'm finding the cofactor of A. So cofactor of A, I'm denoting by CA, which has elements as, so A11 has cofactor as C11, A12 has cofactor as C12, then C13, then C21, C22, C23, then C31, C32 and C33. Everybody understood that part, or shall I re-explain that? Cofactor part, everybody got that? Now the beauty here is simply nothing but this. If you choose any row or any column from a determinant and you multiply it with its cofactors, with its corresponding cofactors. Let's say here I have chosen the second column and I am multiplying those elements with its corresponding cofactors. which means A12 with C12, then A22 with C22, and then A32 with C32. Then mark my words, it will always give you the determinant of that matrix. Are you all able to digest my statement, or shall I repeat that? What I'm saying here is a very simple, a very insightful, and a very interesting fact that if you choose any row or any column of a matrix and you multiply that row or that column's elements with its corresponding rows or columns cofactors, then it will always give you the value of the determinant. Can someone in the comment box tell me why? Can you tell me why is it happening? I hope most of you must have already realized, sir, if you have chosen A12, so what is C12? For A12, C12 will be this minus this. And it already includes the sign because C12 means 2 plus 1, that is 3. So it will already be negative. So that sign scheme which we were following while expanding the determinant, I don't have to care about that because C12 will take care of it already. Do you remember that? Then I wrote A22. What did I write? I write A22. So with A22, I'll remove this and this, which means I'll multiply this with this. And C22 would meant not only this product, but the sign scheme as well. 2 plus 2 is 4. So plus sign will come and that plus sign will be handled by C22. So that expansion of determinant which I was doing previously, that I was taking care of the signs with cofactors, I don't even have to take care of the signs as well. Yes or no? Yes or no? Similarly, when I wrote the next element A32, so I removed this and this. I'll multiply this with this, minus this with this. And with that, I'll get C32, but with that sign where 3 plus 2 is 5. So there will be a negative sign in it, which C32 will already contain. So I will not have to bother about that. Everybody understood that logic? What if we multiplied with minor? In that case, Vinayak, you have to explicitly put the signs. You wouldn't get the value of the determinant. So if you want to get the value of the determinant, you got to take care of the signs as well. So if you're simply putting M12, M22, M32, so you'll just get a random number. But if you want the actual value of the determinant, you got to put the signs. So minors with the proper signs are cofactors. So there, if I'm writing the cofactors, I don't have to bother about the sign scheme. And there, when I started this chapter's discussion in this marathon, I already told you in the beginning that this is the sign scheme we follow. Now you must have understood or developed the logic, why are we following that sign scheme? And the fact where I told you that any row or any column you choose, you multiply that by its corresponding cofactors, you will always find the value of the determinant. That proves that with whichever row or column you want to expand a determinant, you will always get the same value of the determinant. Do you remember that result? Everybody? Now with that, if you have gotten a decent clarity on minors and cofactors, let's discuss few more things where I am bringing you one more very insightful fact here. And there I'm treating it as a poll. Let me ask you a question. Tell me, what do you think should be the answer to this question? But before you answer this question, look at the theorem here. If there is an n-order determinant, so 2 by 2, 3 by 3, 4 by 4, of course, mostly you are restricted to a 3 by 3 only as per your syllabus. So let's say there is an n-order determinant, so 2 by 2, 3 by 3, that kind of order. Then, if you are finding the determinant of cofactors of a matrix, then it will always be equal to the determinant of that matrix raised to the power n minus 1. So whatever you have just said is absolutely not understood by us. Can you re-explain? Yes. I am simply saying you a simple fact here. Shall I get back to the previous example only? Here. This one. Let me bring it here. Hold on for a while, students. This one. Have a look at this. This is your A. I can find its determinant, which will be determinant A. This is CA. I can find its determinant, which I'm denoting by determinant of CA. Now, look at this very insightful, interesting, beautiful property which says that cofactor which you have created by taking the cofactor matrix which you have created by taking the cofactors of corresponding elements of this matrix A, and if you wish to find out its determinant, you truly don't have to. It will be actually equal to this determinant raised to the power n minus 1, and in our case n is 3 because this order is 3 by 3. So this will be determinant A raised to the power 3 minus 1, which is determinant A to the power 2. So let's say if I tell you that there is this matrix A and if its determinant is, let's say, minus 4. I'm not giving you all of its elements. I'm already telling you that its expansion gives you the value of this determinant as minus 4. And if I ask you what will be the determinant of the matrix which is created by taking the cofactors of all of its elements, then what will you say? Will you not say that, sir, the formula suggests a very simple conclusion that this will be equal to determinant of A raised to the power n minus 1. N is 3 in our case. 3 minus 1 is 2. So it is determinant of A to the power 2 minus 4 to the power 2 is 16. So determinant of this matrix will be 16. Is it not absolutely simple, easy, and doable? And if you have gotten that clarity, can I ask you this question right now? Everybody, can you help me with the answer to this question? We are told that there exists a determinant 1x, x square, x square, 1, x square, 1x, and its determinant is given as 3. Okay, that's great. And then I'm asking you the value of the determinant of this matrix. If some of you are paying attention, I am saying you to apply a very simple observation. Please pay attention here. If I ask you to find the cofactor of 1, remove this and this, what you get is x cube minus 1. Is it not x cube minus 1? Cofactor. If I ask you the cofactor of x, remove this and this, x square minus x cube. So, am I making, no, I'm really sorry. It should be x square minus x square, that is 0. But that 0 should come with a negative sign because for cofactor, this is 1, 1, this is 1, 2. So 1, 2 means 1 plus 2, that is 3. 3 means odd, so it should be minus 0, but 0 or minus 0 doesn't matter. Are you getting my statement? The next conclusion. Can you help me with the cofactor of x square? Sir, cofactor of x square will be remove this row and this column. So what are you now left with? This into this minus this into this. Yes or no? So this is x minus x to the power 4. I hope you got this. We have gotten this x minus x to the power 4, and then I'm following the sign scheme plus minus plus. So I need not put any sign additionally here. Everybody with me on this. So somebody, Deeps, has already gotten this. That's brilliant. I hope most of you must have cracked it. Sir, all you're given here in this determinant is nothing, but they all are cofactors of these elements. Which means what? You don't have to expand it, solve it for x, find that x and put it here and then find the answer. No. You don't have to do it. Then what are we supposed to do? Sir, this is a matrix. This matrix is cofactor of it. So if this is a 3 by 3 matrix, its determinant is 3. Its cofactor matrix determinant will be, I hope we have just discovered a property, will be 3 to the power 3 minus 1, which is 2, which means 9. How many of you got this? How many of you understood this? Is everyone clear on this? Have you all gotten a decent clarity on this? And let me see whether you have gotten the answer as 9 or not. So how many of you got the answer as 9? I think it was Kartikeya Keshri. That's great. That's brilliant, Kartik. Now, shall I move towards the next question in that case? There comes one more question. But before I explain you this question, I'd like to tell you some important applications of determinants in coordinate geometry. So determinants in coordinate geometry is what we'll be exploring now. Shall we get started with that discussion? Everybody with me so far? I hope there is no confusion on whatever is explained. Now, with that, I'll tell you one simple conclusion which you should carry with yourself is this, that let's say, sir, I have a triangle in 2D plane. and this triangle has vertices as A1, B1, A2, B2, and A3, B3. And if I'm asked to figure out the area of this triangle, so in coordinate geometry, you must have learnt that, sir, area of this triangle will be given by half of determinant of A1, B1, 1, A2, B2, 1, A3, B3, 1. So that's your first application of determinants, which you see getting applied in coordinate geometry. But rather than learning it like this, I'll suggest you something totally different. Sir, what do you mean by that? Let's say you have a random quadrilateral or pentagon or hexagon or hectagon or any figure at all. And let's say this has its vertices given as x1, y1, vertex A. Vertex B is given as x2, y2. Vertex C is given as x3, y3. Vertex D is given as x4, y4. So one of the methods of finding the area of this quadrilateral is, sir, divide it into two triangles. Find this area, add both of the areas. That is absolutely a doable approach. But what if I suggest you again another shortcut for finding the area of any polygon, It is not merely restricted to a triangle or a quadrilateral. Even if you are given a heptagon or a hexagon, you can apply this stair method. Sir, how? Look at this. The stair method says that area of this quadrilateral ABCD can be given by half of modulus of stair of. Sir, what is the stair? We'll talk about that 4 studies. I'll create a short on it. Don't worry about that. So stair here is given by, you take any vertex first of all, let's say x1, y1. Now it's absolutely your choice whether you want to go clockwise or anti-clockwise. Let's say I have chosen to go in the clockwise direction. So after x1, y1, I'm writing the next pair x2, y2. Then I'm writing the next pair x3, y3. Then I'm writing the next pair, which is x4, y4. And then I will write the last pair again with which I started. Which means if I started with x1, y1, I'll write that in the end, I'll close this stair and this mod. Sir, okay, this looks good, but how do you expand this stair? What is the meaning or sense of this stair? The sense here is really simple. It says 1 by 2 stays like that, modulus stays like that, but stair is expanded as x1 when multiplied with y2 stays like that, x1, y2. But from down to up, if you go, you write it as x2, y1. I repeat, from bottom to down, if you are going, it will be plus x2, y3. And from bottom to down, if you are going, it will be x3, y2, and so on. And you do all this value and you take its mod, because area ultimately is supposed to be positive. This is an extension of determinants only, but I hope you have understood this result as well for finding the area of any shape, pentagon, hexagon, hectagon, and its area. Are you all comfortable with this method? All the participants? Everybody got this? Now, there are some more. There is one more very beautiful and interesting property. Let's say there are 3 lines. A1x plus B1y plus C1 is equal to 0. Second line is A2x plus B2y plus C2 is equal to 0. Third line is A3x plus B3y plus C3 is equal to 0. These are the 3 lines L1, L2, L3. Now, I am told that these 3 lines are concurrent. This line 1, line 2 and line 3, they are concurrent. What is the meaning of line being concurrent? So when somebody says or claims that lines are concurrent, it means all of them are passing through one single point. So if I'm asked to verify, to check whether these 3 lines, these 3 given lines are concurrent or not. So how will I do that? I will do one thing. Sir, I solve these 2 lines. So by solving these 2 lines, I'll find their point of intersection, say x1, y1. And I'll push that x1, y1 into this third line. And if that x1, y1 satisfies it, I think all the three lines are passing through one unique point. That means they are passing through one common single point. It means they are concurrent. Absolutely great idea. But what if I tell you that you could get this result with one more approach? Sir, what is that approach? That approach says that if you are given three lines and you're supposed to check whether they are concurrent or not, there comes a method which is called determinant method. So the determinant method says here, you find the determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3. Let's call it delta. Now, if this delta is 0, we say lines are concurrent. If this delta is not 0, we say lines are not concurrent. A very good observation, Vinayak. Did you all get this property? Did you all understand this property? Now, there is one more application of your determinants in two-coordinate geometry. Technically, there are a lot many, but the results which you already know without determinant are also very handy and useful. So I wouldn't confuse you with the determinants rules unnecessarily. So there, one more result I want to talk about here is, let's say there is a second degree equation in two variables, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. Let's say this is a second degree equation in two variables. Now in 11th standard, I'm sure you must have studied this. You must have studied this, that it can represent either a pair of straight lines, yes or no, or it can represent a conic. Now when it represents a conic, it can represent either a circle or a parabola or an ellipse or a hyperbola. Do you remember that? But let's say I ask you to tell me to find out whether this pair of straight lines or this equation, second degree equation in two variables, whether it represents a pair of straight lines or conic. Can you tell me that? At just or by just looking at this equation. Then I'll tell you yes, without even solving it further or simplifying it further, you still have an approach. Yes, what is that approach here, students? That approach is such an interesting approach that all now you need to find out is delta again. But here that delta is given by A, B, C at your principal diagonal. So A, B, C, the principal diagonal elements. Then H, G, F, H, G, F and H, G, F placed here. Which means if you find out this delta, and again, if you find out that this delta is finding or found to be as 0, you say that yes, sir, it is representing a pair of straight lines. And if it is non-zero, in that case, you say, sir, it represents a conic. Now, conic means circle, parabola, ellipse or hyperbola, whatever it could be. But here, this is how you figure it out. If you are still confused, I'll give you an example here. Let's try and solve this. In this particular one, I am told that, sir, 2x square plus 7xy plus 3y square plus 8x plus 14y plus lambda is equal to 0. This is a second degree equation in two variables. We need to find out the value of lambda. We need to find out the value of the lambda if it represents a pair of straight lines. Now, do you all remember a result which we have just discussed? Pair of straight lines. So if it represents a pair of straight lines, sir, delta has to be 0. What is delta? ABC, HGF, HGF. Do you remember that? Sir, what is A? 2x square. So this is A. 3y square. This is B. Constant term is your C. Yes or no? Coefficient of xy is 2h. So h will be 7 by 2. Coefficient of x is 2g. So g will be 8 by 2. Coefficient of y, I hope you remember, is 2f. I hope you remember HGF. So this will be f rather 2f. So f here will be 7. Did you all understand how did I find them? Everybody? With that, will you not say, sir, finding delta is this absolutely easy task because delta here will be A, B, C at diagonal. So A is 2, B is your 3, and C is your lambda. Then what I write is HGF. What is H? Sir, H is 7 by 2, G is 4, and F is 7. Then again HGF, which is again 7 by 2, 4, and 7. Now, if I am told that it represents a pair of straight lines, will I not say that delta will be 0, which means this value has to be 0. Did you all get that? Did you all understand it? With this, I'll be saying that if this is 0, you have again Sarrus rule or standard expansion. Whatever you wish to use, you can. Let's say I'm using Sarrus rule or standard expansion. Both are fine. So let's say I'm expanding it with respect to row 1. So this 2 I'll write. With this 2, 3 lambda. I hope you got this. Minus 7 into 7, which is 49. Yes or no? Then plus, minus, plus. So it should be minus 7 by 2 times 7 by 2 lambda. I hope you are getting it. Minus 4 into 7, that is 28. Plus, because plus minus plus, plus 4. 4 times, I hope you are getting it, 7 by 2 into 7, which is 49 by 2, which is 49 by 2, minus 4 into 3, which is 12. And this value should be 0. This value should be 0. Did you all get this result, or shall I re-explain this, all the participants? With that, can I skip that calculation part so that we can save some time? So you just calculate this linear equation in lambda. You solve this linear equation in lambda. You will get a value of lambda, and that lambda will be the answer to this question. So I'm skipping one single last step here where you are solving it for lambda, which you all know how to. Can I move ahead from here? Then after this, we'll now start discussing properties. But before I start discussing properties, let's take a break of 10 minutes and then we'll resume. So it is 8:15 right now. We'll resume at 8:20 or 25 possibly. So the class will resume at 8:20, let's say, for a while. Okay, is that okay? So let's take a 5 to 10 minutes break. I hope that's okay. Okay, so here we are. Just give me a quick update. Am I clearly visible and audible, all these students? Can I begin with this discussion now? So the break is over. Let's resume. Pay attention to this part. I hope you also had a break. Properties of determinants. Sir, why do we discuss them? Somebody in the beginning was saying that, sir, I'm confused with the properties. So this is the section where you should be paying a lot of attention. Along with this, please remember all the participants that with the properties, you expand the determinant more quickly. Sir, how do we apply them? That's exactly what we'll be learning one after another. Let me begin with the first one. Please understand, the value of a determinant remains unaltered when rows are interchanged or changed into corresponding columns and vice versa. What does it mean? In the world of matrices, this is called taking the transpose. So let's say if you have a matrix A and this is 2, 3, 4, 7. And if I take its transpose, so transpose of a matrix means you are interchanging rows into columns. So first row is 2, 3, so you are making it the first column. Second row is 4, 7, so you are making it the second column. So if you could convert this matrix into its transpose, which means you converted rows into columns or columns into rows, vice versa, whatever you wish to write it. Trust me, whether you find the matrix A's determinant or determinant of A transpose, it will always be same. This is not just true for a 2 by 2, but it is true for all the matrices of square order, for square matrices, which means here, this will be 2 into 7 and this is 4 into 3. 14 minus 12, that is 2, yes or no? 2 into 7, 4 into 3, that is again same, 14 minus 12. I think you got the idea. Everybody understood that first property, or shall I re-explain that? Can I move ahead from here? Second property. Second property says, if you have any two rows or columns you have chosen and you are interchanging them. Sir, what is the meaning of that? I'll explain it. Pay attention to this part. Let's say this is a matrix. Or I'll write a determinant only. Why to confuse you unnecessarily? So this is a determinant. Let's call it delta, which has 2, 1, 2, minus 1, 0, 7, 3, 5, 6. Right or not? Now, it will have a certain value. So after expanding it, I can find its value. Right or not? Now, let's say I am given one more determinant, which is, pay attention to this part, 2, minus 1, 3, 2, 7, 6, and 1, 0, 5. Now, if I ask you the value of this determinant, most of you would be saying, sir, they look almost identical except for one change, where if this second column and third column are interchanged. In place of second column, I have written the third column 276. In place of third column, I have written the second column 105. So I have performed an operation where I have interchanged column 2 by column 3. So in the world of matrices and determinants, you write this operation in this manner: column 2 bidirectional arrow, column 3. This means column 2 and column 3 are swapped, they are interchanged. So when you interchange a row by a row or a column by a column, then what happens to the determinant is simply nothing, but it becomes minus of it. For example, let's say this has a value k. So the value of this determinant will be minus k. Simple, straightforward, direct. Did you all get that, or shall I repeat it? Give me a quick update in the chat box, then we'll move ahead. Everybody understood that? Sir, what if you interchange now column 3 by column 1? Let's say you are performing this operation one more time. You are interchanging column 3 by column 1. So then what happens is 105 becomes your first column. 276 stays as your second column because you're not doing anything on this. And then 2 minus 1, 3 becomes your third column. I hope you're getting it. So this will now again become negative of this, which means it will be negative of delta, which means it will be delta. Will it not be? Yes or no? Yes or no? Give me a quick update in the chat box. Have you all understood that what happens when you interchange a column by a column or a row by row? Yes or no? So I hope you got this idea that there, when I was talking about this simple property, or if I apply this transformation here, that in a determinant, if I interchange any two rows or any two columns, there what happens is, if you're interchanging any two rows or any two columns, if they are getting interchanged, then the sign of the determinant is changed. The sign of the determinant is changed, and the numerical value of the determinant still remains same, unchanged or intact or unaltered. Give me a quick thumbs up in the chat box if you have understood this part, or shall I re-explain this? With this, one thing is clear. I hope if, let's say, number of interchanging, if you are applying it odd number of times, you will get a negative value of delta. If that number of interchanging of rows and columns you are performing even number of times, you will get positive of delta. Shall I explain you that? I hope you got it. Everybody, I performed this column and column interchanging twice, 2 times, even number of times. I got it as positive of delta. But if I'm performing it only 1 time, odd number of times, I'm getting negative of delta. That is self-explanatory, I think so. Second property of determinant, I hope is very well understood by everyone. Shall I move ahead from here? Then the next one, if I explore here, third property, it says if 2 rows or columns for a determinant are identical, then the value of the determinant is 0. Let's say there you see a determinant, which has the first row and second row are absolutely identical. I hope you are noticing it. A1, B1, C1, A2, B2, C2. So if you ever see any 2 rows or any 2 columns of a determinant to be identical, you should not hesitate in saying that its value will be 0. Let's say it is 3, 2, 1, then it is 1, 7, 5, and this is again 3, 2, 1. So here, I hope you are noticing that, sir, column 1 and column 3 are clearly identical. And if any 2 rows or any 2 columns are same, you can, without even evaluating, write the value of the determinant as 0. Everybody got this? Shall I move ahead from here? Then the next property comes into picture. What is that? The next one is if the element, this is the one of the most important properties, pay attention to this part. If the elements of any row or any column of a determinant be each multiplied by the same factor k, then the value of the determinant is also multiplied by k. What does it mean? I'll give you a numerical example here. Please pay attention to this. Let's say there is this determinant delta, which is given by 2, 3, 7, 4, 1, 0, 8, 2, 5. Yes or no, everyone? Yes or no, everyone? There. Let's say I am seeing that here you could have written the first column as 2 into 1, 2 into 2, and 2 into 4. And this is 3, 1, 2, and this is 7, 0, 5. I am explaining it in the reverse manner, the property which we have just discussed. There, the property says that this 2, 2, 2, you can take common out of this entire determinant. Are you able to digest this property, all the participants? In determinants, you can take any element common out of any row or any column. Are you getting it or not? So here I could have taken this 2 common, which means it will be 2 times 1, 2, 4, 3, 1, 2, and 7, 0, 5. Sir, what are you trying to say? All I'm trying to say is merely a simple fact, which means that here, if you expand this and you find its value, and you expand this and you find its value, so the value of this determinant multiplied by 2 will be equal to the value of this determinant. Because of only one simple property getting applied here, that if there is a value which exists in any row or any column, that you can take out from the determinant. This is an interpretation of this property, but how do we treat this property as? This property is actually like this. let's say there is a determinant given to you. Let's say there is a determinant given to you, A, B, C, D, E, F, G, H, I. Let's say this is a determinant denoted by delta. Now, I want to multiply any row or any column by a scalar quantity. Let's say I want to multiply second column by, let's say, lambda. So there it becomes A, T, G, C, F, I. But if I'm multiplying second column by lambda, let's say as per the need of the question. So this will be lambda B, this will be lambda E, and this will be lambda H. Of course, it will be a certain determinant. It will be a certain determinant. But there you remember, and you need to remember, that all you have done is you have multiplied either a row or a column of this determinant by a certain fixed quantity. Then nothing changes here except for one thing, that its value remains delta, but with this lambda. Did you get this part? All I'm trying to simply make you understand is that if I look at it from a different perspective, I'll say that I can take this lambda common from the second column, because in determinants you can take a certain value common from either any row or any column. So if I take this lambda common out of this, so lambda comes out, and then you are left with A, D, G, this is B, E, H, this is C, F, I, and shall I tell you what is it? A, B, C, D, E, F, G, H, I, that's your delta only. So that's your lambda delta. That's exactly what I have been trying to say here. Have you all gotten a decent clarity on all what I've said so far? Have you all understood this property? Shall I move ahead from here, all the participants? Shall we explore the next property? Now, this is a very beautiful one. Again, a very insightful one. Let's say I am given a determinant, which is A1 plus X, B1, C1, A2 plus Y, B2, C2, A3 plus Z, B3, C3. This is what I'm given. I can split this determinant as a sum of two determinants where I am supposed to keep any two rows or any two columns same, which means splitting when I'm doing B1, C1, B2, C2, B3, C3, B1, C1, B2, C2, B3, C3, I'm keeping intact. But this A1 plus X, I'm splitting as A1 plus X, A2 plus Y, I'm splitting as A2 plus Y, A3 plus Z, I'm splitting as A3 plus Z. Did you all understand this, or shall I repeat this? Give me a quick update in the comment box, all the participants. So whenever you are asked to split a determinant as an addition or difference of two determinants, how we do that? Did you get an idea on this, or shall I re-explain this? Quickly respond, everyone. The next one, again an interesting one, and I'll say the most important one, which is again very highly loved and cherished by NTA. Let's look at that. It says, I will give you a very simple, a very decent, a very straightforward example. Let's say there is a determinant delta which has values, let's say 1, 2, 4, 7, -1, 2, 0, 5, 3. This is delta. Yes or no? Now, let's say row 2, I am willing to update. Row 2, I am willing to update. And row 2, I am willing to update by row 1 plus 7 times row 3. What did I just say? I am taking row 1 and adding it with 7 times of row 3. And that part I am replacing here in row 2. Let's say I'm adding this R2 as well, let's say for a while. So this is the operation I'm doing. What am I doing here is row 2, I am updating by row 1 plus row 2 plus 7 times of row 3. Everybody understood this operation first of all? Now, how do we apply this operation? Sir, you are performing an operation on row 2, which means clearly row 1 and row 3 will remain intact, which means 1, 2, 4 it will be 0, 5 and 3. Yes or no? But what is going to happen to row 2? Pay attention to this part. It will be row 1 plus 7 times row 3 plus R2. So row 1, which is 1, I hope you're getting it. 7 times row 3. So 1 plus 7 into 0 is 1 plus row 2. So that is 7. So 1 plus 7 is 8. So that will be 8 here. Then in column 2, row 1 plus 7 times row 3. 7 into 5, 35. 35 plus 2 is 37 plus row 2. So 37 minus 1 is 36. Everybody with me so far, all the participants? Then the next one. On column 3, it will be row 1, which is 4, plus 7 times row 3. I'm really sorry. 7 times row 3 is 21, plus 4 is 25. 25 plus row 2. 25 plus row 2, that is 27. Now, some of you must be wondering, sir, why did we do this? Or what is the point of doing it? Or what is the need of doing it? I'll tell you a simple fact here that even if I have done it, trust me and mark my words, this will still remain delta. Can you believe that? 8, 36, 15. No, I think so. 4, 3 into 7, that is 21. 21 plus 4 is 25. Plus 2 is 27. It will be 27 deeps. Now, I am saying you with utmost clarity, with clear confidence, that even if you expand this determinant, do it by yourself. And if you expand this determinant, do it by yourself. Trust me, you will get the same value, delta only. Did you get my statement? Did you all understand that statement? So if I get back to the property I was talking about the simple property, the value of the determinant does not change. I think that's exactly what I've said. Delta remains delta. If elements of any row or column, let's say row, are increased or diminished by equimultiples of the corresponding elements of any other row or column. Did you all understand that, or shall I repeat it? All the participants in the comment box quickly respond. Are you able to digest this? Let me try and explain you this particular operation which we are performing here on this. Of course, this is A1, B1, C1, A2, B2, C2, A3, B3, C3. That's your delta. On this delta, I am performing an operation. Which operation? I am saying that in column 1, make a change. What change? In column 1, updated by column 1 plus m times column 2 plus n times column 3. Column 1 plus m times column 2 plus n times column 3. So what does it mean? Column 1 A1 plus mb1 plus nc1. So a1 plus mb1 plus nc1, that value you update in column 1. Then second row, a2 plus mb2 plus nc2. So a2 plus mb2 plus nc2, that value update in column 1, second row. Similarly, a3 plus mb3 plus nc3. So a3 plus mb3 plus nc3 you update in row 3, of course in column 1. And even despite doing this operation, mark my words, it will still remain this delta only. You do it by yourself, you do that expansion by yourself, you will find the same expansion which you get by this expansion. Is my language understandable? Have you all been able to digest what I have just said so far? Everybody with me on this? Shall I move ahead from here, all the participants? Everybody got this conclusion? Now, from here, let us move ahead towards a question. Let's solve this. I think no options are given. So let's see how many of you are able to write the answer to this question. I've already started the poll. Sir, how do we use this feature of poll? This is Pylon's application, which you can download from Google Play Store or Chrome Play Store. And then you can access this polling feature and you can participate in this live polling. Yes. Sir, is that the only use or utility of this? No. Let's say you're watching any random video on YouTube, recorded or live. You want short notes of that topic. You want previous year's questions on that topic. You want mind maps. You want quiz on it. A currently, instant quiz on it. It will do everything for you at absolutely no cost, at absolutely free of cost. That's the feature of this application, Pylons. Getting back to this question, how do we do this? we need to find out, although you won't be proving it because this is a proof-based question, so there cannot be any poll here. So I'm really sorry. I'm getting back to the discussion. We are asked the value of this determinant is to be 0. How do we prove that? Can somebody quickly tell me in the comments the idea or the suggestion or the approach through which we can do it? Anyone in the comments? I hope everybody is realizing that if omega is a complex cube root of unity, if omega is a complex cube root of unity, what does it mean? What does it mean, students? Does it not mean that omega here is a root of this equation x square plus x plus 1, which when solved gives you two roots, omega and omega square. They are simply the symbols. We denote usually omega by 1 plus root 3 iota by 2 and omega square by minus 1 minus root 3 iota by 2. Do you remember these two results? Although all of this is not needed in this question, I hope in complex numbers chapter in 11th standard you must have studied 1 plus omega square is 0 if omega represents cube root of unity, and that property, if you know, you apply it here and you'll get the answer. How? Have a look at that. Here I'll say, what is 1 plus omega square? That is 0. So in column 1, I'm updating it by column 1 plus column 2 plus column 3. What would that mean, sir? That means 1 plus omega square. So this will be 1 plus omega square. This will be omega square plus 1. So this will be omega plus omega square plus 1. In the third row, it will be omega square plus 1 plus omega. So it will be omega square plus 1 plus omega. What about the column 2 and column 3? They are remaining unchanged. So omega square 1 and 1 omega. With that, can you help me with this first column here? Anyone? 1 plus omega square is 0. So this is 0. This is 0 and this is also 0. So all these entries in the first column are 0. Yes or no? And if all these entries in the first column are 0, will I not say the expansion of this determinant 0 into its cofactor plus 0 into its cofactor plus 0 into its cofactor? Even if you follow the sign scheme, I hope you're understanding, it will be 0, because if any row or any column of a determinant contains all the values to be 0, I will say its value is going to be 0. Everybody got that? All the participants? Have you all gotten a decent clarity on what is said so far? Did you all understand the solution? Now, let's talk about the next result. What does it say? It says, if each element on one side or other side or both sides of the principal diagonal determinant is 0, which means if you are having lower triangular, upper triangular or diagonal matrix. I repeat, if you have a lower triangular matrix or an upper triangular matrix or a diagonal matrix, which means principal diagonal above of it all are 0, principal diagonal below of it all are 0, principal diagonal except for this all are 0, then mark my words, its expansion is always product of the principal diagonal elements. This determinant's expansion is always product of the principal diagonal elements. Please remember that. Don't invest or waste your time in expanding it unnecessarily. Just directly write A into B into C. It will be the value of the determinant. Everybody got that? Everybody understood that? Shall I move ahead from here? All the participants, give me a quick update. Now, when you apply these properties, especially that equimultiple property, there you got to take care of one very crucial thing, which is this. Let's say I am applying operations. We know how to apply operations now. So if I'm applying operations on determinants, then when you're applying the operations, so either you apply operations on rows or on columns, but don't apply operations on both simultaneously. I hope you got this statement. Let's say it is a 3 by 3 determinant and I'm applying operations. So for a 3 by 3, at a time, maximum number of operations which you can perform should be 2 only, 3 minus 1, 1 less than the number of rows or columns. Got my point, everyone? Everybody got this? First point is, if I'm applying operations on a determinant, then I need to ensure that one row or column must remain unchanged, or in a different language, I'll say one less than the order of the matrix will be the number of maximum operations you can apply at a time. Got my point? Second conclusion. This second conclusion, I think, is an extension of that previous first property only. The third one, if the row operation, if the row or column which is changed by multiplied by a non-zero number, then the determinant should also be divided by that. Let me explain that part. So far, let's say there is a delta, which is of course a determinant, which is 2, 1, 2, 3, 5, 7, 4, 1, 3. Let's say this is your delta. Now, let's say I am performing an operation where I'm saying that column 1 should be updated by 2 times column 1 plus 3 times column 3. Let's say you're doing it. So there you are making a mistake actually. You cannot do this. You can actually, but you have to manage it. You have to compensate for it. How and why and where? Let's talk about it. This is 2 times of C1. So if you're updating column 1, what you should usually do is column 1 should be updated by column 1 plus anything multiplied to column 2 or column 3. That would have been justified. But if you are multiplying this column 1, which you are updating here, also by 2, then please remember this determinant's value will also get multiplied by 2. So if you want to apply this operation, it's okay, but that whole value should be divided by 2 to balance it out, which means here, let's say I have done this operation. So if I'm multiplying column 1 by 2 and that column only I'm updating here, so I have to add this 1 by 2 here, append this 1 by 2 here to balance it out. And there it remains balanced. There it remains balanced, which means here column 1 is getting updated with the 2 times of column 1 plus 3 times of column 3. So 4 plus 12. 4 plus 12 is how much? 16. Then 2 plus 3, that is 5. Then 4 plus 9, that I think is 13. Column 2 is 3, 5, 7, and this is 4, 1, 3. Sir, you said that we can apply operations and the value of the determinant does not change. Yes, I said so. But I said that part when I mentioned this very clearly. There I told you that this column 1 should remain column 1 here as well. If you're taking equi-multiples, then you take equi-multiples of column 2 and column 3, but not of column 1. But if I'm updating column 1 by 2 times of column 2, then I have to balance it out by dividing it by 2 further. Did you all understand this property? Everybody understood this? Have you all gotten a decent idea that what am I trying to suggest to you all here? Everybody? Shall I move ahead from here? All the participants. With that, let us try and prove that whether this expansion looks like this or not by all what we have learned so far, right? Let's apply all the learnings which we have learned so far. So what I'll suggest here to do is that can we do this thing that let's say in column 1, I'm performing an operation column 1 plus column 2 plus column 3. With that, what do I get? X plus 4 plus 2x plus 2x. So 2x plus 2x is 4x. 4x plus x is 5x. So it will give me 5x plus 4. 2x plus x plus 2x, that is again 5x. So it gives me 5x plus 4. 2x plus 2x plus x, that again gives you 5x plus 4. Yes or no? But I haven't done anything on the second column and the third column. If you want, you can. Let's say I'm performing one more operation, column 2. I'm updating by column 2 minus column 3. Although if you don't want, you can, leave it here as well. But even if you want to, it is absolutely fine. With that, if you want to, you can. If you don't want to, you can stop there as well. The second row or the second column remains 2x, x plus 4, 2x. Third column remains as 2x, 2x and x plus 4. Everybody got this? This is still your delta only. If it was denoted by delta, this still remains as delta because I have ensured that column 1 still remained as 1 into C1. And if I introduce any m or n here with C2 and C3, the value of the delta remains intact. The basic property which we have learned so far. With this, what I'll be suggesting you all to do here is that can we take this 5x plus 4 common from here? So if I take 5x plus 4 common from here, I hope you remember I can take a certain value common from any row or any column. So 5x plus 4 I'm seeing in first column. So I can take that common. In determinants, it is allowed. With that, first column gives you 1, 1, 1. Second column stays as 2x, x plus 4, 2x. And third column stays as 2x, 2x, and x plus 4. Everybody with me so far? I hope no confusion on whatever is done. Now, the next operation which I'm interested in applying here is this, that sir, I am seeing a lot of ones. So can I convert them into zeros? Because if I do so, the expansion will be easier. So if I try to do this thing, what thing, sir? Column 2, I'm updating by column 2 minus column 1. Column 3, I'm updating by column 3 minus column 2. Can I do so? I hope it's okay and doable. At a time, I'm applying operation either on only columns or rows. This is a 3 by 3 determinant. So maximum number of operations which you can perform is 3 minus 1, which is 2. So I'm fulfilling all the conditions. I'm not violating any law. So with that, what conclusion do you receive here is 5x plus 4 stays outside. That you don't touch. I'm really sorry. I'm making a mistake. It's not column, it's row. I'm really sorry. I did not notice. So with row 2, I'm doing row 2 minus row 1. And with row 3 also, I'm doing row 3 minus row 1. Are you okay with that? Because this 1 minus 1 and this 1 minus 1 will give me a 0 here. That's why I'm doing it. So row 1 remains intact. You don't do anything with the row 1. Yes. So row 1 remains 1, 2x, 2x. Yes or no, everyone? Then what happens with row 2? Row 2 minus row 1. So 1 minus 1, that is 0. Then x plus 4 minus 2x. So that I think is 4 minus x. This here gives you 4 minus x. And this here gives you 2x minus 2x. That gives you a 0 here. Then in row 3, I am subtracting row 1. So from row 3, if I subtract row 1, 1 minus 1, that is again a 0 here. Then 2x minus x minus 4 is clearly minus x minus 4. So I'll write it as minus x minus 4. Are you getting it? Then x plus 4 minus 2x is, I think, again 4 minus x. That again gives you a 4 minus x here. With that, I hope now you are clearly noticing that, sir, if you want to expand it, you can expand it along with column 1. Why column 1? Because column 1 contains maximum number of zeros. So that expansion will be simpler. So this factor 5x plus 4 stays outside. You don't touch it. But what happens with the column 1? These values I don't have to bother. I'll just simply expand it with respect to this 1. This into this minus this into this. So 1 into 4 minus x, 4 minus x. So 4 minus x into 4 minus x is 4 minus x square minus 0. So that 0 I'm not writing. So this is the expansion, which is what we were supposed to prove. Everybody understood that result. Everybody understood how do we use the properties in the expansion of determinants. Are you all comfortable with that? Shall I move ahead from here? Now Kramer's rule comes into picture. What is that? Kramer's rule says that, let's say if there are 3 equations, if there are 3 linear equations in 3 variables, a1x, b1y, c1, a2x, b2y, c2, a3x, b3y, c3z. d1, d2, d3 are the constant terms. Great. That's good, Deeps. So the mathematician Kramer suggested that you define 4 determinants. First determinant delta, which will be given by a1, b1, c1, a2, b2, c2, a3, b3, c3. That will be the delta. Then you define delta 1. What will be delta 1? Remove the coefficients of x and replace them by the constant terms. What does it mean? a1, a2, a3 in delta should be replaced by d1, d2, d3. That will give you delta 1. How do we define delta 2? Replace the coefficients of y in delta by the constant terms. So b1, b2, b3, I'm substituting or replacing by d1, d2, d3. That gives you delta 2. Delta 3, how do we find? Replace the coefficients of z, which are c1, c2, c3 in delta by the constant terms d1, d2, d3. So c1, c2, c3 are replaced by d1, d2, d3, and that's how I got delta 3. So we got 4 determinants. Now you expand them and find these 4 values. What is the point of doing all this, sir? The point is that delta 1 when divided by delta gives you x, delta 2 when divided by delta gives you y, and I need not tell you delta 3 when divided by delta gives you z. So this is what Kramer suggested. So why are we doing this? Have you understood it now, or should I re-explain that? This is another way of solving system of equations, linear equations. Great, I'm really proud of you. I hope everybody understood that. Can I move ahead from here, all the participants? Now there, I hope this simple catch is understood by everyone. Sir, to find x, y and z, we are dividing delta 1, delta 2, delta 3 by delta. So it is clearly understood that the denominator can never be 0, which means delta should never be 0. Yes or no, everyone? Which leads us to some more conclusions. And these are the conclusions on which JEE asks questions. What are these conclusions, sir? Let's talk about them one after another. The first one, if you see delta, which is what? A1, B1, C1, A2, B2, C2, A3, B3, C3. The determinant formed by coefficients of x, y, and z. So if that delta is not 0, then please remember your system, Praneeth, there is a lot of spamming going on, so I am not able to distinguish what is real and what is fake, and that's why I'm not supposed to respond. But if you have genuinely gotten this, I'm really proud of it, which I've already mentioned. Now let's focus on what we are supposed to cover. Right, Praneeth? I hope you got my intent. Now, the delta, if it is not 0, you can unhesitatingly say that this system will have a unique finite solution. I hope you remember in 2D, let's say there was an equation with two variables x and y. So we say that it has a unique solution if a1 upon a2 is not equal to b1 upon b2. It is actually that only with three variables. Are you getting my point? Similarly, let's say if delta is 0, then there are two cases. If delta is 0, then there are two cases. If delta is 0, then the first case may say that, sir, delta 1, delta 2, delta 3, all of them will become 0. And the second case says that at least one of delta 1, delta 2, delta 3 will be non-zero. If along with delta 1, delta 2, delta 3, all of them are 0, then you say that they have infinite solutions. And we call this solution or system of equations to be consistent. So two cases, pay attention. If delta was not 0, there was a unique solution. If delta 1, delta 2, delta 3, all were 0, the system has infinite solutions, and then also the system of equations is said to be consistent. So consistent, you call it in two cases, unique solution or infinite. Unique means delta non-zero, infinite means all 0. So I'm left with one more case. Which case? Sir, if delta is 0, but at least one of delta 1, delta 2, delta 3 is non-zero. Not all are 0. If all are 0, infinite. But if at least one of them is non-zero, then remember this as a fact, that system of equations will have no solutions and it will be called an inconsistent system of equations. Give me a quick yes or no. Did you all get this, or shall I repeat it? I'll try to give you one more version of it. Let's say you're solving system of equations. So it all depends on delta. So once you have figured out delta, it will be either 0 or it will not be 0. If it is not 0, you say the system of equations is consistent and it has a unique solution. Did you all get my point? But if delta is 0, again there are two things. Two things means delta 1, delta 2, delta 3 are also 0. There also you say system of equations is consistent, but this time it has infinite solutions. But if at least one of delta 1, delta 2, delta 3 is non-zero, then you say this system of equations is inconsistent, and there you claim that it has no solution. Have you all understood this whole story? Are you comfortable with this part? I hope you will remember it, because JEE Mains in Advanced ask you questions based on this hierarchy. They sometimes tell you that a system of equations is consistent. So if it is consistent, there are two possibilities. Delta can be 0, delta cannot be 0. I hope you will remember all of these cases and the kind of questions asked by JEE Mains based on these scenarios. Let's solve one. So this question here says system of linear equations. We are given system of linear equations, 3 equations we are given, yes or no? And I am told that this system of linear equations has infinitely many solutions. It has infinitely many solutions. And then it is asking you lambda plus mu. So the moment somebody says that it has infinitely many solutions, what does it mean? Does it not mean that delta 1, delta 2, delta 3 all are 0? Because it has infinite solutions, infinitely many solutions. So I think the job is done. What I'll do first is, sir, I'll find delta. What is delta? Delta you define as 1, 1, 1, then 1, 2, 5, then 2, 3, lambda. Can I use Sarrus rule for expansion here so that we can very quickly do that? So I'll repeat the first 2 rows. So 1, 1, 1, then 1, 2, 5. Do you all remember that Sarrus rule we have just discussed? With that, this will be 2 lambda. Then this will be 3. And this will be 10. Yes or no? Give me a quick update. Minus. This will be 4. Then this will be 15. And then this will be lambda. I hope you got this. And this we are said that it has infinite solutions. So first of all, delta should be 0. And if delta is 0, will I not say that this will be equal to this? Because this difference is 0. So both the values should be same. If you don't get this part, I think you can simply solve it by yourself and get the final value of lambda. So lambda you'll get as 2 lambda minus lambda. That will be lambda. 3 plus 10 is 13. 15 plus 4 is 19. 13 minus 19 I think is minus 6. Minus 6 goes to the other side. You receive lambda as 6. That's your first conclusion. Everybody got that part? Sir, the story doesn't end here. You're supposed to solve it further because you need to find out the value of mu as well. How do we find mu? Let's work on mu now. Sir, for mu, I'll say let's work on delta 1, let's say for a while. What is delta 1, sir? Delta 1, coefficient of x are replaced by the constant terms. So coefficient of x are what? 6, 10 and mu. And then coefficient of y and z remain intact. So 1, 1. It will be 1, 1. Then 2, 5. It will be 2, 5. And then it will be 3 lambda. But what was lambda? I think lambda was 6. Yes or no? So this will be delta 1. And we know that this should also be 0 in finite solutions. So again, Sarrus rule I'll use. So 6, 1, 1. And then 10, 2, 5. Are you all okay and comfortable if I apply Sarrus rule now? You know how to do that, everybody. So with that, this will be 6 into 2 into 6. That is how much? 36 into 2, 72. Plus, this will be 10 into 3 into 1. That's clearly 30. Plus, this will be mu into 5 into 1, which is 5 mu. Minus, what I get next is, I hope you're paying attention, 1 into 2 into mu, that is 2 mu. Then 5 into 3 into 6. So 5 into 6 is 30. 30 into 3 is 90. So this here is 90. Everybody give me a quick update. And this is 10 into 1 into 6, which here is nothing but 60. Everybody got this? With this, 5 mu minus 2 mu. And of course, this is also supposed to be 0 because it has infinite solutions. So 5 mu minus 2 mu, that is clearly 3 mu. 72 plus 30, right? And 90 plus 60. So 72 plus 30 is what? 102. And this is 150. Yes or no? So from 102, if 150 is subtracted, I think it should be 48. but it should be minus 48, goes to the other side, becomes 48, and I think it is 3 because 16 into 3 is 48. So mu we receive as 3. So lambda was 6, mu we receive as 3. The answer will be, did I make any mistake? Did I make any mistake? Lambda plus mu, right? Lambda we have gotten as 6. Mu we have gotten as 3, right? Mu will be 3, yes or no? Let me recheck it. 6, 10 mu. 1, 2, 3. 1, 5 lambda. I hope we were right in terms of calculation. Did I make any mistake here? The value of lambda plus mu is what they are asking. I think there is no typing error here in this question. I believe so. Am I making any mistake? Let me cross check it one more time so that we will be assured. I'll check it again. So 1, 1, 1, 1, 2, 5, 2, 3 lambda, right? This is your delta. So 1, 1, 1, 1, 2, 5. So 1, 2 lambda, 1, 3, 1, and 2, 5, 1. Yes, correct. 2, do 1, 3, 5, 1, and lambda. So 2 lambda minus lambda is lambda. 13, 19. 13 minus 19 is what? 6. So lambda is 6. It was absolutely correct. There what I did was 6, 1, 1, 10 to 5, and mu 3 lambda. So lambda was 6. So 6, 1, 1, 10 to 5. Then when I multiplied, 36 into 2, 72, I think. Then this is 30. Then it should be 5 mu. Then the next one will be 2 mu. 5 into 6 is 30. 30 into 3 is 90. Then it is 60. Then what I did was 72 plus 30, that is 102. And this is 150. Correct me if I'm wrong. 5 mu minus 2 mu is 3 mu. So 102 minus 150, I hope, is 48. So mu should be, oh, I'm really sorry. Why am I writing it as 3? I'm really sorry. I don't know what was I doing. I think I told it to be 16, but I mistakenly wrote it as 3. And nobody responded. Surprising. I hope you remember mu will be 16. This is how you commit silly errors, right? Despite being absolutely correct, you came up with something such silly, right? So lambda will be 6, mu will be 16. 16 plus 6 will be 22. That will be the answer, which is your option C. I don't know why did I do that. I hope you understood that explanation. Everybody. Are we all clear on that? Can I move ahead from here, all the participants? Again, we'll take a 5 minutes break and then we'll resume. So it is 9:10. We'll resume at 9:15. So we are taking a 5 minutes break. I hope that's okay. And we'll resume at 9:15. Okay, so now I hope I'm clearly audible and visible. We'll discuss the part which is again very highly loved by JEE. Yes, it is again something which JEE loves because JEE asks you questions based on it. What does it say? It says there are three equations, but this time luckily you are noticing that all the constant terms are zero. All the constant terms are zero. So if all the constant terms are zero in this case, it is called homogeneous system of linear equations. Of course, there are three equations in three variables. Sir, if you are simply applying a basic logic here, why are you not suggesting that, sir, why do we have to solve this? Are you not noticing that if I want to solve this, I'll say the solution here, the values of x, y, z here will be 0, 0, 0. Why? Because you put 0, 0, 0 here, it will be 0. 0, 0, 0 here, it will be 0. 0, 0, 0 here, it will be 0. So 0, 0, 0, that is x, y, z should be 0, 0, 0 each. Yes or no? I accepted it. And yes, it is called the trivial solution. This is called the trivial solution. But let's say, since it is mathematics, there are three equations. And except for 0, 0, 0, of course, 0, 0, 0 is definitely an answer. But apart from 0, 0, 0, there is one more answer to this question. Which means apart from 0, 0, 0, there is one more triplet or some other triplets exist which also satisfy this system of equations. Let's say for a while, I put 2, 3 and minus 5, and luckily by putting x, y, z as 2, 3 and minus 5, all the three equations are satisfied. So instead of 0, 0 also, there is a non-zero solution as well. Non-zero means these values are non-zero. At least one of them is non-zero. So if a non-zero solution also exists, then we call it to be a non-trivial solution. Everybody getting that? Everybody getting that? Especially the ones who are watching it for covering this determinant in one shot. Now, one thing you should keep with you here is a simple fact. Let's say this has a non-trivial solution. Non-trivial means apart from 0, 0, 0, there is one non-zero value as well, or there are some non-zero values as well, which also satisfy the system of equations, which means this has non-trivial solutions. So to verify that, what Kramer suggested was that you find delta, and if this delta is found to be 0, you will say it will have non-trivial solution. If this delta is found to be non-zero, you will say it will have only one trivial solution. What is non-trivial solution? Non-trivial solution means here any other non-zero triplet xyz will also satisfy this equation, system of equations. What is delta? A1, A2, A3, B1, B2, B3, C1, C2, C3. Did you all get this, or shall I repeat it? Give me a quick update. Even if it is still confusing, I'll explain all of this with an example. Shall we do that? Now, what is this question saying? It is saying system of equations. The moment you see 0, 0, 0, I hope you say it is not merely a system of equations, it is system of homogeneous equations. Yes or no? And they are telling you that this system of homogeneous equations has a non-trivial solution. It has a non-trivial solution. So the moment somebody says if it has a non-trivial solution, that means coefficients A1, A2, A3, that is 1, 1, 1, B1, B2, B3, that is root 2 sine alpha, then it is cos alpha, and this is sine alpha. C1, C2, C3, that is root 2 cos alpha, this is sine alpha, and this is minus cos alpha, my dear students. This is your delta. Yes or no? And if it has non-trivial solution, then what we know is that, sir, delta should be 0. Everybody, first of all, give me a quick confirmation. Did you all get this conclusion? That why are we having this? Tell me honestly, everybody got that, all the participants? Now with this, when I proceed further, what I do or see next is something really amazing and exceptional. I think I'll simply expand it. So either I use the properties of determinants, or rather than wasting my time there, I'll use Sarrus rule very quickly. So if I apply Sarrus rule, I'll repeat the first two rows. So 1, 1, 1, root 2 sine alpha, cos alpha, and this is root 2 cos alpha, and sin alpha. Although you can save your time by writing cos alpha as cos, I mean C, and sin alpha as S, so that you can save some time of yours. Now with that, if I'm applying my Sarrus rule here, what do I get? I hope you're noticing it. 1 cos alpha, this is cos square alpha, yes or no? Then 1 sin alpha root 2 cos alpha, so this is sin alpha root 2 cos alpha, so this is root 2 sin alpha cos alpha, yes or no everyone? Then you have the third diagonal, 1 root 2 sin alpha, which is plus root 2 sin square alpha. Give me a quick update on that. Are we going great? I hope nothing wrong I have written so far. Then this minus that should be 0. So this and that should be equal. Sarrus rule, I hope you remember. So what is that? That will be this. So root 2 cos alpha. So it is root 2 cos square alpha. Give me a quick update on this. Everybody getting that? It will be root 2 cos square alpha. Then sin alpha 1. So it should be sin square alpha, sin alpha 1. And the next value will be root 2 sin alpha cos alpha with a negative sign. So it should be minus root 2 sin alpha cos alpha. Did you all get this, or shall I repeat it? Everyone, give me a quick update on that. Everyone, give me a quick update on that. Are we clear on whatever I've done so far, all the participants? Now, if I start rearranging whatever I've done here, I think I'll start getting this question converted into a trigonometric equation based questions. So NTA says that trigonometric equations is omitted, and you are clearly seeing trigonometric equations being used here almost everywhere. Now, if I start simplifying, cos square alpha, if I bring here and club it with this sin square alpha, will I not get a 1 on the right hand side? Are you comfortable with this? Then 2 sin alpha, root 2 sin alpha cos alpha will be 2 root 2 sin alpha cos alpha. Did you get that, or shall I repeat it? Everybody with me on this? Then this and this, so it will be plus root 2 sin square alpha plus root 2 sin square alpha minus cos square alpha. I hope you got this conclusion as well, all the participants. Now you tell me, have you not studied in 11th standard only 2 sin theta cos theta is sin 2 theta? So this result I'll be writing as root 2 sin 2 alpha. If I take negative sign common from here, it will be cos square alpha minus sin square alpha, that is cos 2 alpha. So this will be root 2 cos 2 alpha is equal to 1. Now one thing I'm willing to do here is, if I divide both these sides by root 2, sir, why are you doing this? Sorry, both these sides by 2. If I divide both these sides by 2, so this is root 2 by 2, this is root 2 by 2, this is 1 by 2. Sir, why are you doing this? Have patience, you'll understand. Root 2 by 2 is 1 by root 2, so this is 1 by root 2 sin 2 alpha. This is 1 by root 2 cos 2 alpha, and this is clearly nothing but 1 by 2. That is what I have received and gotten. Tell me honestly, are you all comfortable with whatever I've done so far? Give me a quick update, students. Tell me honestly, have you all understood this particular part? Now, sir, what do we get with this result? I think we'll get something really interesting here. What is that? Pay attention to this part. Sin A cos B plus cos A sin B if I apply. So this is sin 2 alpha. I'll keep it as sin 2 alpha. Then this 1 by root 2 can I write as cos 45 degree, which is cos pi by 4, plus cos A, which is cos 2 alpha, sin B, so 1 by root 2 I'll write as sin pi by 4, which is 1 by 2, which I'm writing as sin 30 degree, which is sin pi by 6. Tell me honestly, are you all listening and understanding whatever is being done comfortably? Now, with this, I think I have the result. Sin A cos B cos A sin B is sin A plus B. So this is sin 2 alpha plus pi by 4, and that is sin pi by 6. Now, what are we asked? Let me read the question again. It is asking you that alpha lies between 0 to pi by 2. Then they are asking you the value of alpha. They are asking you the value of alpha if this system of equation has non-trivial solution. So I think I need to now solve this. So I hope you remember, this is what you must have studied, that if sin theta, this is what you must have studied. If sin theta is equal to sin alpha, then the general solution theta here is given by n pi plus minus 1 to the power n alpha. Do you all remember that? So that logic, if I apply here, this is 2 alpha plus pi by 4 is equal to n pi plus minus 1 to the power n pi by 6. This is what you study in trigonometric equations. Have you not studied that? So with that, pi by 4, if I push on the left hand side, this will be 2 alpha minus pi by 4. And if I divide both the sides by 2, I'll get alpha as n pi by 2 plus minus 1 to the power n pi by 12 minus pi by 8. Correct me if I'm wrong. N pi by 2, pi by 12, pi by 8. Great. Now, this is your alpha. I need to check it. I need to ensure that alpha lies between 0 to pi by 2. So let me try alpha as 0. Sorry, n as 0. So if n is 0, I'll be getting alpha as 0. This is 0, so it is pi by 12 minus pi by 8. What would that be? I hope you are clearly getting it. If it is 12, it is 8. I think 24. First of all, of course, you could say that here, what I'll do is 24, right? 8, 3, 12, 2. So if I do 2 pi here, this will become 12 into 2. If I do 3 pi here, it will become 8 into 3. So 2 pi minus 3 pi is minus pi. So it is minus pi by 24. And I hope you are noticing it that minus pi by 24 is less than 0. So this value is discarded. Now if I try n as 1, so n as 1 means what? Pi by 2. 1 means minus. So this is minus pi by 12. And this is minus pi by 8. Again, I think 24 will do the justice. So this will be 12 pi by 24. This is 2 pi by 24 and this is 3 pi by 24. I hope you are understanding. I'm just taking the LCM. So with that you receive alpha as 12 minus 2 minus 3. I hope I'm correct. So 12 minus 5 I think is 7. 7. So alpha you receive as 7 pi by 24 and 7 pi by 24. Had it been 12 pi by 24, it would have been pi by 2. But it is 7 pi by 24. It is less than pi by 2. Getting it, everyone? So 7 pi by 24 is your option C. It's Dinah. I hope I'm pronouncing your name correctly. It's a live class, already going live. Thank you so much, Deeps, for your response. I hope everybody got this. 7 pi by 24, option C will be the answer. Shall I move ahead from here? Now, they say that even if you want, you can differentiate a determinant as well. I'll not confuse you with this particular expression. I'll simply tell you how do you differentiate. Let's say there is delta, or let's call it a function, and it is given as determinant, let's say x square, x 1, then 3x, 2, 3, and then 4, 5, 7. Let's say this is a determinant. Sir, you want to expand it and then differentiate it? Definitely you can. Otherwise, you can differentiate it while keeping it as a determinant. Yes. Let's say I want to find ddx of f of x, which of course you may call as f dash x. So if you want to find it, what you can do is you can do it either row wise or column wise. So what does it mean? You differentiate first column first. So it will be 2x, 1, 0. Other two columns you don't touch at all. Plus, then you differentiate the second column and you keep the first and third column as it is. So first column is x square x 1. Differentiating second column, 3x will be 3, 2 will be 0, 3 will be 0. And keeping the third column as it is, 4, 5 and 7. Plus, keeping the first and second column as it is and differentiating the third column, which means here x square x 1 and then 3x 2 and 3. Third column has all constants, so their differentiation will be 0, 0, 0 each. Good. That's brilliant. With that, I hope you all have gotten a crystal clear clarity that how do we differentiate a determinant. Sir, you have done it column wise. Can we not do it row wise? Yes, you can. If you want, you can differentiate it row wise as well. First row, second row, third row. Keeping other two rows intact, addition of this. That's exactly what they have written over here. Let's say I'm given an expression, delta x, which has rows and columns as functions of x, and I'm asked to find out delta dash x. So I'm differentiating first row, keeping other two rows intact, plus derivative of second row, keeping other two rows intact, plus derivative of third row, keeping other two rows intact. Everybody got this. I hope there is no confusion on that. And the same you could have done column wise as well. Okay, Deeps, that's good if it is new to you. Now, there is one more conclusion I want to give you all, that let's say if someday you encounter something like this, something like what? Something like this, where you are given delta x as only one row or one column in x, other two row or column in terms of constant. Then what happens? Then let's say I find the delta dash x. So what will be delta dash x? Delta dash x will be derivative of first row, other two row as it is, plus first and third row as it is, derivative of second row, but it will be 0, 0, 0. That will be 0. Determinant whole will be 0. Then plus first and second row as it is, derivative of third row. Third row is constant, so 0, 0, 0. Whole determinant will be 0. Somebody is saying, sir, I have backlog in Lakshya English batch. May I do my backlog clear from here? Yes, you are definitely allowed to. Why should you not? So first of all, I'm trying to tell you is that if any one row or any one column contains terms in x, delta dash x will not be a sum of three different determinants because the other two has become 0. So it will be just one determinant only, and this only one row differentiated. So if I find a delta 2 dash x, delta double dash x, which means second derivative of delta x, then again will you not say, sir, you differentiate this row again, other two row remains intact? Are you learning this? Are you digesting it? With that, I hope we have reached to a substantial conclusion where we are concluding this, that sir, if I'm finding its nth derivative, the nth derivative of delta x, it will be nth derivative of this, nth derivative of this, nth derivative of this, other two rows remaining intact. Yes or no? Give me a quick update on this. Are you all able to digest this statement? Even if you are not able to, you will get a decent clarity with this example. How? Have a look at that. This says that this is how the delta x function is defined. And then they're asking you to find out the nth derivative of f of x when x is 0. I hope nobody is saying that, sir, put x is equal to 0, then differentiate it. No. You differentiate it first and then you finally put x as 0. Deeps, you will understand it with this example. Don't worry. Great. What I'm trying to say here is nth derivative. So when you're trying to find out the nth derivative, first column has terms in x. Second column and third column are constant terms. Second column and third column are constant terms. So let's say I am finding delta dash x. So what will be delta dash x? First derivative. X to the power n will be nx to the power n minus 1. Cos x will be minus sin x and sin x will be cos x. The other two columns will remain as it is, n factorial cos n pi by 2 and sin n pi by 2. Then the third column 2, 4, 8. Now these, what I'm saying here is that what you do with derivative of determinant is plus first and third row as it is, derivative of second column. So derivative of second column will be 0, 0, 0 because it is constant, plus first and second column as it is, derivative of third column. Third column has constant terms, so it will be 0, 0, 0, 0. So 0, 0, 0 in any row or any column will give you the value of determinant as 0, which means I don't have to write them at all. So are you realizing now that I'll not be dealing with three determinants each time? I'll be getting this determinant only every time I differentiate it. Everybody got my point here? And if you have gotten my point, this is your delta dash x. If this is delta dash x, I hope everybody has noticed. If I'm interested in delta double, I'm really sorry. If I'm interested in delta double dash, which means second derivative here. So nx to the power n minus 1 will be what? I hope you now see the pattern. n minus 1, x to the power n minus 2. This sin x becomes what? Cos x, so it will be minus cos x. And this cos x becomes minus sin x. Yes or no, everyone? Yes or no, everyone? Yes, exactly. Everybody got this? Are you all comfortable with what all being is said? Now, with that, I hope I need not differentiate the other two rows. It is absolutely understandable now. If I show you what will be the third derivative here, delta triple dash x. So I hope now you are comfortable. N minus 2 will come to the front, so it is n minus 1, n minus 2, then x to the power n minus 3. This cos x becomes what? Sir, minus cos x will become, cos x is minus sin x, so this will become plus sin x. And what will this sin x become? It will become minus cos x. Everybody got this, or shall I re-explain this part? Tell me honestly. So what happens next? I think when I find the fourth derivative, I'm finding delta 4 dash x. So this is delta, although you can write it in terms of Roman as well, whatever you want to. I hope you're understanding it. Fourth derivative I'm doing here. So there again, n minus 1, n minus 2, n minus 3. So this will be n minus 1, n minus 2. Although I don't have to do it like this, but to make you understand it more clearly, I'm just doing it. And there sin x becomes what? Cos x. So this becomes cos x. And minus cos x when differentiated gives you what? Minus of minus sin x, which is plus sin x. I think I have gotten cos x and sin x only, but this is changing here. Yes, there is a shortcut. I don't have to do it n times. There is a shortcut. I was just showing you the pattern that after fourth one, it will show me a pattern with these. So there is a cyclicity here of 4 quadrants if you're noticing. And with this, I hope you're understanding, if you differentiate it n times, it will be n factorial only when x is, I hope you're understanding, 0 or not, whatever it is. Because ultimately with the last term, I have understanding when I'm differentiating it 4 times, it is n minus 4. So when I'm differentiating n times, it will be x to the power n minus n, which is x to the power 0. So I'll be left with n minus 1, n minus 2, n minus 3, and so on until what? 1. So are you not thinking that if I find the nth derivative here, if I try to write the nth derivative here, this delta nth derivative here, this is not delta x to the power n, this is nth derivative here, this whole thing will be nothing but n factorial, yes or no? But sir, this will not be cos x and sin x. Yes, I got this. But if you see the pattern, you will be in a position to generalize that. Look at this. Look at the beautiful expression here. Sir, when we differentiated what was delta x? Delta x was cos x. So delta dash x was minus sin x. Okay, I'm just showing you this. Just look at this. It was cos x. Then it became what? Minus sin x. Then what did it become? Delta double. It became minus cos x. It became minus cos x. Then what did it become? Then it again become sin x. And then when I differentiated it, it started the same chain again. What happened with sin x? Let me show you that as well. So it was sin x. Then sin x when differentiated became cos x. I hope you're understanding it. Cos x when differentiated becomes minus sin x, and this becomes, of course, minus cos x. Correct me if I'm wrong. Sin x is minus sin x, and it is minus cos x. And when you differentiate this minus cos x, it again leaves you to this sin x. I hope you're getting it. This sin x again gives you that cos x in the beginning, and this minus cos x again gives you that sin x in the beginning. So that chain again comes into picture. Now, look at this part here. I am telling you one simple observation here, that can we generalize this derivative? This is what you study as nth derivative of certain standard functions when you study the chapter differentiation. But there we are already using it in determinant. So let me try and tell you this. This is minus sin x. Can I write it in terms of cos x? If I use cyclicity, minus sin x, can I write as cos pi by 2 plus x? Are you okay if I do so? Can I do that? Second quadrant, pi by 2 will make it sine, and second quadrant will make it negative. So it will be minus sin x. This is minus cos x. This is minus cos x. Can I write minus cos x as cos pi plus x? Pi plus x will push it in the third quadrant, and then minus cos x. Getting it or not, everyone? Getting it or not, everyone? All the participants. I hope no confusion on whatever I've done so far. Sir, can I get IIT this year with 102 marks in advanced? It depends on a lot of other factors as well. So I don't know a lot of other parameters, but if you're fulfilling the criteria, you would definitely, right? Now, I want you to talk about sin x. Now, sin x. This sin x, can I write as cos 3 pi by 2 plus x? First of all, 3 pi by 2 will convert it into sine. And this 3 pi by 2 plus fourth quadrant, their cos is positive, so it will be sin x. Are you seeing a certain pattern here? Let me show this to you one more time. This is cos x. Can I write it as sine pi by 2 plus x? Because pi by 2, second quadrant, and their sine is positive, so it will be cos x. This here, minus sin x, can I write it as sine pi plus x, third quadrant? I hope you're understanding it. Then this I am writing as sine 3 pi by 2 plus x. Have you noticed a generalized result? Sir, first derivative 1 into pi by 2. Second derivative 2 into pi by 2. Third derivative 3 into pi by 2. So nth derivative n pi by 2. Yes or no? Yes or no? So shall I directly write the nth derivative here? The nth derivative here, this will be cos n pi by 2 plus x, and this will be sine n pi by 2 plus x. Yes or no? Tell me honestly. Tell me honestly. But sir, this was not the question. You were asked to figure out something else. I know that. Let's try and do that. What are we asked? We were asked this derivative when x is 0. So when x is 0, then we need to find it. Okay, so let me replace x by 0. So when I replace x by 0, this x becomes 0. This x also becomes 0. So cos n pi by 2, cos n pi by 2. Now, if any two rows or any two columns of a determinant are same, two columns are same, its value will be 0. That's the answer to this question. Shall I re-explain that? Everybody got this? Everybody understood this? All the participants with me? I hope there is no confusion on that. Now, sir, how do we integrate? So whether it is indefinite integration or definite integration, how do we do that? Let me try and help you with that. This is del x, where only one row or one column contains terms in x. Sir, if more than one row or one column, then can we go ahead with this the way we were differentiating a determinant? No, 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 no. Now, what do I mean by that? Here, let's say if I wish to integrate a determinant where only one row or one column is given in terms of the variable x, then here you can do it with integrating that particular row or column and keeping other rows or other constant columns intact. What if more than one row or one column are given in terms of the variable x? Then you cannot do anything. Simply expand it first and then integrate. Did you all understand that statement, or shall I repeat it? Everyone got that? All the participants? Now, with this, I am giving you a simple conclusion. Let's try and understand the whole idea with this example. Now, if I wish to integrate this, sir, here I'm seeing more than one column are there in terms of x. So if you are willing to integrate it, first you got to expand it and then you can. I totally am aligned with that idea. Yes, agreeing with that. But if I know some properties of determinant, this is delta x, which is given by 1 x square x cube, then you have 6 4x and 3, and you have 9 x and minus 7, then can we do something here? Can we do some adjustments here? I can. Just pay attention to this result here. Let me take x common from this second column. So if I do so, this x becomes 1, this 4x leaves with the x, and this x square becomes x. And what I have done is I have taken that x common like this. I hope you remember, we can take any value, any number, any factor common from any row or any column in a determinant. Do you remember that result, everyone? Now this entity, I can push to any row or any column. I hope you remember that result. So this x, I'll deliberately push to the first row. So 1 into x is x into x is x square, and x cube into x is x to the power 4. And with that, it still remains that delta x. But the beauty here is that this has now only one row or one column in terms of x. And now I can integrate it without even expanding it. Did you all realize that? So with that, if somebody is asking you to find its integration from 0 to 1, I'll put integration 0 to 1 here. I'll put integration 0 to 1 here. And I'll put integration 0 to 1 here. I hope you got this. Everybody with me on this? And from here, yes, they all are inspired from JEE Mains and Advanced only. If you solve the previous year's questions, you will see these questions. Maybe the numerical value getting changed, but these kind of questions will be seen there. All the questions which I'm keeping in these sessions are inspired from JEE Mains and Advanced only. And some of them are JEE Mains and Advanced question only, right? Everybody got this? From here, shall I tell you how to integrate it? Do you not know integration of this and this? Do you not know how to put the upper limit and lower limit? And then you can finally find out the answer by expanding that determinant. So shall I leave this question at this stage? The tricky part here, which was supposed to be done or known by you, I have already explained. Can I move ahead from here, all the participants? With that, someone is highly curious and restless. Sir, is 6 classes possible in one day, 1 class, 2 hours? Okay, Sohan, I9P. Okay, that's good. Shubha, 8th one will be 1-3. Let me verify that. It will be x cube or not. So, yes, it will be x cube. I'm really sorry. It was actually x square, so it should be x cube. Thank you so much for highlighting that. I think I made a mistake here, so it should be x cube. I think otherwise, rest of the things are fine. X square, x and x cube. Yes, great. With that, let me explain you the next result, which is the summation part. Everybody understand that? Now, the way we applied integration, the same fashion you apply summation. Summation also has that restriction. Which restriction? The restriction says if there is an expression in R, of course del R, where only one row or one column contains terms in R, but other rows or other columns are absolutely constant. And if I apply summation on that determinant, so one of the approaches is you expand this determinant and then you apply that summation, and you know how to distribute summation. You must have understood that in sequence and series. But the beauty with determinants is that if only one row or one column contains that variable R on which you are applying that summation, then you can distribute that summation to that one row or one column the way we distributed integration. Did you all get this, or shall I repeat that? Now, those who are very much concerned about coverage, I am telling you, this is your Lakshya JEE in English 2027 backlog marathon session of chapter determinants. As I have already told you in the very beginning of this session, depth we may not cover, but width will be covering here. Depth means number of questions in a certain limited time you cannot practice, because we got to cover the whole theory, the whole chapter, the whole concept. So width means I have tried covering all the concepts from this chapter determinants, although superficially, not in a very in-depth manner, because to bring depth here, I have to introduce more questions, which we have done in proper lectures, which you can see on our Lakshya JEE in English batch. So if you're so curious about that, you can visit our batch. You will definitely find all the classes properly aligned with apt and appropriate number of examples, so that that depth can also be brought, about which you are very much worried, my dear friend. Can we conclude it here? So I hope summation is also same as integration. With that, we are calling it a day. Sir, is this lecture always sufficient for us? Never. Is this lecture sufficient in terms of revising the theory? Yes. So, sir, if we want to get expertise on determinant, because determinant is one of those most important chapters, which when clubbed with matrices becomes so lethal that 2 to 3 questions are asked from this unit, yes, you should get more in-depth conceptual clarity on that. Sir, how do we bring that? By practicing more previous year's questions. So width we have brought. Now let's bring depth. Got my point? Sir, how are we going to bring depth? First of all, you can have this PDF. Sir, how are we going to have this PDF? By following our WhatsApp channel. Right after the session, this entire PDF will be uploaded. The next lecture of mathematics will be next Saturday. It will be of matrices. Okay, Deeps? Now, I repeat, this entire session, the determinants one-shot marathon, which we have just conducted, its entire PDF you can avail by following our WhatsApp channel. Right after this session, it will be given to you. I think I have discussed it in a lot of marathons, which we have conducted on this channel. I think probably in the next class we'll do it. Yes, Black Mystery, we'll be conducting an IIT class as well. Don't worry about that. We have already started planning it, and very soon you'll get an update about that. I know that you are much into ICER and all. Yes, we'll be conducting. And I hope along with that, simultaneously, you have started studying biology as well. PCMB it is. Now, PDF you'll receive on our WhatsApp channel. Link to the WhatsApp channel is given in the description. Now, after revising the notes, after doing the proper revision of the notes, which means going through the theory very quickly and very quick examples which we have given, start practicing questions. And I'll say if you are already a JEE aspirant, start solving mains PYQs and then advanced PYQs. Initially begin with the easy ones so that you start gaining the confidence, you understand conceptual clarity, and then move towards moderate and tougher ones. So I think you have gotten a decent clarity on that. Great, great, great. Thank you so much. You have been a great audience. I'm glad, Deeps, you were there since the beginning till end, and I am sure you must have learned a lot. Calling it a day. Thank you so much. You all have been a great audience. Take good care of yourself. Good day. Good night, everyone. Good night. Great. Solve modules.